Hello all, my name is Krishnaik and welcome to my YouTube channel. So guys, here is one amazing one-shot video on Langchain in order to learn generative AI. So if you are interested in creating amazing LLM application or Gen AI powered application, then this specific video is definitely for you. If you don't know about Langchain, it is a complete framework that will actually help you to create Q&A chatbots, RAG application and many more. The most interesting thing will be that I will be covering all the paid LLM models along with that open source LLM models, even though that they are hosted in Hugging Face. So we will be getting to know each and everything about it and how we can specifically use in Langchain. So I hope you enjoy this particular video and please make sure that you watch this video till the end. So thank you. Let's go ahead and enjoy the series. Before I go ahead, guys, since there should be some motivation for me also, so I will keep the like target to 1000. Please make sure that you hit like, share with all your friends, and we'll also keep a target of 200 comments. Okay, 200 comments. I know you will be able to do it. So let's keep that specific target and let's understand what all things we are going to learn about Langchain. And then we'll also understand the second topic that we are going to understand in this specific video is about the Langchain ecosystem and how it is related to each other. Now, right now in the Langchain documentation, if you probably see the recent updates that are there, mainly most of the modules revolve around this particular topics in Langchain. Okay, so over here you'll be able to see LangSmith. Here you'll be able to see LangServe. If I talk about LangSmith, recently I had also made a video on this, just a simple video, but I will try to create more videos on that when we go in this specific series. So LangSmith is, if I probably give you some examples, it'll help you to monitor your application. It will help you to debug your application. So in short, whatever MLOps activities is specifically required with respect to monitoring, deploying, debugging, testing, so third point, I will say testing. You can specifically use this amazing module in Langchain that is called as LangSmith. The best thing will be that all the reports, all the analytics, you'll be able to see very much easily in this ecosystem itself, in the Langchain ecosystem. So there is a dashboard in Langchain which you'll be able to see it. Okay. Now, how we are going to use this entire technique in some projects, we'll be seeing completely end to end, and we'll also be able to understand this. So if I talk about LangSmith, it is mostly of if I say LLM ops. Okay, so this part that is right now required in many companies, so that part we'll also be able to cover it. That is the reason why I like Langchain, because it is providing you the entire ecosystem irrespective of any LLM model. Okay, any LLM model. Now coming to the second thing over here, you have LangServe. Let's say that you have created your LLM application. You obviously want your entire LLM application in the form of APIs, right? Without writing much code. Yes, you can write the code from scratch with the help of Flask or some other libraries. But here LangServe uses something called as fast API. Okay. And because of this fast API, creation of this particular APIs becomes very much easy. So we'll be also able to understand it before the deployment. If I have actually created my own LLM app, how I can actually create all the services in the form of APIs, that we'll try to see with respect to the LangServe. Now coming to the next thing, there are some amazing concepts and important concepts in Langchain, from data ingestion to data transformation and all. In that, major topics are with respect to chains. We'll try to understand about chains, and probably in the next video, once I probably start the practical implementation, the first thing that I'm actually going to cover is with respect to chains. And I'm also going to discuss something called as agents and retrieval, right? Not only that, you'll be able to see there is a concept of LCEL. Okay. Now in this LCEL, we will be discussing, and this full form is Langchain Expression Language, right? So there are a lot of concepts that are specifically used in LCEL. We'll also see that how it is basically important while you're building, what all techniques it actually has when you're creating your own generative AI powered application, right? Along with that, there are three main topics also, which I will be able to cover it while I will be discussing all these things that is about model IO, retriever, agent tooling and all. These are concepts that you should really know. The main aim of this entire series is not to make you understand in theoretical concept, but it's more to understand how you can create amazing generative AI applications irrespective of any LLM model. Now see guys, one of the questions that I get from many people, hey Krish, I'm using this specific LLM model. I don't have OpenAI access. I don't have API access. Tell me what should I do? Let's say many people say that, hey Krish, I don't have credit card for OpenAI, right? can you show me some examples with respect to open source models like Google Gemini or some other Mistral? What about open source models, right? See, LLM over here, as I said, Langchain is an amazing framework to build the entire application. And creating the best LLM is already a rat race. So if I probably say this is a rat race by tech giants, right? So Google will be competing, Meta will be competing, Anthropic will be competing, OpenAI will be competing. So you don't even have to worry about this, right? Whatever models will be probably coming up in the future, don't worry about this. The main thing is that how you can use this LLM app in a generic way to build any kind of application. So here, whatever model it may come, you just need to stay up to date, right? Which model has the best accuracy and all. That will basically happen over here. Right? Later on, all the integration part will be completely generic. Okay. Now let's go ahead and understand the entire LangChain ecosystem. Like what are the very important things? So this is the diagram that I have already taken from the LangChain. So as I already discussed with respect to LangSmith, the first model that you see over here, we basically say it as observability, right? And with the help of LangSmith, you will be able to do debugging, playground, evaluation, annotation, and monitoring. When I say annotation, it's all about creating your own custom data set, which will require with respect to fine tuning or creating your Gen AI powered application. The next thing is with respect to deployment. And recently, right now, LangServe has actually come. It'll be in the form of API. So here it is written, right? Chains as REST API, whatever services you are specifically providing. LangChain soon will also come up with only one-click deployment mechanism. Once you probably create this entire APIs with the help of LangServe, the next thing is that you just need to deploy it. Okay. Then, and already I have created a couple of videos on LangSmith and LangServe, but don't worry. In this entire series, I'm going to again start from fresh, combine new topics and create a project. Okay. The third thing that you really need to understand is about templates. Okay. So there are different templates, reference application. With respect to LangChain, you need to understand these three important things: chains, agent, and retrieval strategies. So we'll try to understand how these things work, and understand, guys, you will be able to get the code with respect to Python and JavaScript. But my main aim will be with respect to Python, because in some of the article, it was already said that AGI application is going to get created in Python. Okay. Then you also have some integration components. So we are understanding about the ecosystem, because all these things we are going to discuss in this specific playlist itself. So here you have model IO, here you have retrieval, here you have agenting tool. So retrieval, you also will be having features to read your data set from different data sources, how you can actually create vector embeddings and all are there. Right? In model IO, you have various techniques with respect to model, chain, prompt, example selector, and output parser. And finally, you will be also seeing that we'll be focusing on this amazing thing which is called as protocol, which is basically coming under LangChain core. And here we are going to discuss about LangChain expression language, right? So there are some important concepts like parallelization, fallbacks, tracing, batching, streaming, async, and composition. So all these things we are basically going to cover. And then we will be focusing on end-to-end projects, how you can use all these concepts together, right? Understand one thing, guys. When we use LangServe and start creating REST APIs, we'll also be writing our client side code, so that we'll be able to access those kind of APIs, right? So all these things in the form of ecosystem will get completely covered. Trust me. Again, why I'm saying this is important, because tomorrow, whatever LLM models may come, right? How advanced it may be, LangChain will be a generic framework which will actually help you to build any kind of LLM application. In this video, I will be showing you how you can create chatbot applications with the help of both paid APIs LLM. Along with that, we'll also see how you can integrate with open source LLMs. Now, you should definitely know both these specific ways how you can actually do it. One way to basically integrate any open source LLM is through Hugging Face. But as you know that I'm focusing more on the LangChain ecosystem, and with respect to Hugging Face, I've already uploaded a lot of videos in my YouTube channel and how you can actually call this kind of open source LLMs. But since we are working with the LangChain ecosystem, we will try to use all the components that are available in LangChain. As you all know, guys, this is a fresh playlist, and obviously my plan is that This month I will be focusing entirely on Langchain. Many more videos will be coming up, many more amazing videos along with end-to-end application, fine tuning, many more things is going to come up. So please make sure that we'll keep a like target for every video, and for this video the like target is 1000 and at least 200 comments. And please make sure that you watch this video till the end because it is going to be completely practical oriented. Okay. And if you really want to support, please make sure that you subscribe the channel and take up membership plan from my YouTube channel so that it will help me, and with the help of those benefits I will be able to create more videos as such. So let me quickly go ahead and share my screen. So here is my screen over here, and you will be able to see in the GitHub that you will be finding in the description of this particular video, you'll be having folders like this. So today is the second tutorial. In the first and second we just understood that what all things we are going to learn, but in this is the real practical implementation that is probably there. So as usual, the first thing that we are going to do is that create our VENV environment. How to create it? Conda create -p VENV, Python is equal to 3.10. You can probably take 3.10 version, and I have already shown you how to create virtual environments in many number of videos. Then you will be using .env file. So this will basically be my environment variable. In this environment variable, I will be putting three important information. One is Langchain API key. The second one is OpenAI API key and Langchain project. You may be thinking this OpenAI API key I have kept it as open. No, it is not. I've changed some of the numbers over here, so don't try it out. It will be of no use. Okay. And then the third environment variable that I'm actually going to create is my Langchain project name, that is tutorial 1. I have written it over here. The reason why I have written this, because whenever I try to go ahead and see in my LangSmith, right, I will be able to see, observe the entire, I'll be able to monitor each and every calls from the dashboard itself. How we will be using this, everything I will be discussing about it. Okay. So all these things will specifically get required, and all this will be used in our environment variable. So these are the three parameters I have already created in my .env file. So let's go ahead and start the coding. Okay. And you have to make sure that you code along with me, because this is the future. AI engineering things are basically coming up. I'll just show you initially with the foundation model. Later on, this complexity will keep on increasing. So let's go ahead and start our first code. Now, what is our main aim? What we are trying to do in our first project? Let me just discuss about, because these are all the things that we are going to discuss in the future. But first thing that we will try to create is our normal ChatGPT application. Okay. I'll not say ChatGPT, but a normal chatbot. Okay. And this chatbot will be important. It will be helping you to probably create chatbot with the help of both paid and open source LLM model. So this will be the chatbot that we will be creating. One way is that we will be using some paid LLMs. Now, paid LLMs, one example, I can show it with the help of OpenAI API. Okay, OpenAI API. The second one that I will try to probably show it, or you can also use Cloudy API. So that is from a company called as Anthropic. Okay, that you can do. And one more, I will try to use it with the help of open source LLM. See, calling APIs is a very easy task. Okay. But the major thing is that since we have so many modules, we are going to use Langchain as suggested, right? And in Langchain, we definitely have so many modules. How we can use these modules for different calls. And along with this, whenever we are developing any chatbot application, what all dependencies we have specifically, right? Dependencies. Now, if you probably see this diagram, here you will be able to see there will be model, prompt, output parser. So in our video, in this video, I'm going to see some of the features with respect to LangSmith. I'm going to see some of the features with respect to chains and agents. And I'm also going to use some of the feature present in model and output parser. So all this combination we are going to specifically use. And that is the reason how I'm going to create all the projects that we are doing. Entire videos that are probably going to come up will be much more practical oriented. Okay, so now let's start our first chatbot application. So here I will go ahead and write from Langchain. Okay, from Langchain underscore OpenAI, since I'm going to use OpenAI, import chat OpenAI. Okay, chat OpenAI. So this is the first one that we're going to basically do from Langchain. See, these three things will definitely be required. Then one is chat OpenAI or whatever OpenAI whatever chat model that you are going to use. How to call open source, I will also be discussing about that. First of all, we'll start with OpenAI API itself. Okay, so from Langchain _core dot prompts, I'm going to import chat prompt template. Okay, chat prompt template. So this is the next thing that we are probably going to use, chat prompt template. Okay, at any point of time, whenever you create a chat bot, right, this chat prompt template will be super important, right? Here is what you'll basically give the initial prompt template that is actually required. Okay, the third library that I'm actually going to import is from Langchain _core dot output _ parsers. Okay, import str output parser. Okay, now these three are very important. This string str output parser is the default output parser whenever your LLM model gives any kind of response. You can also create a custom output parser. That also I will be showing you in the upcoming videos. Okay, this custom output parser, you can do anything with respect to the output that probably comes. You want to do a split, you want to make it as a capital letter, anything, right? You can write your own custom code with respect to this. But by default, right now I'm going to use just str output parser. Now along with this, the next thing that I'm actually going to do is that I'm going to use Streamlit as st. Okay, Streamlit as st. Then I'm going to also import os, and since I'm also going to use from .env import load _ .env, so that we will be able to import all our libraries. Okay, so let's see whether everything is working fine or not. Okay, from .env. So here I'm going to basically write Python load _ Python app.py. I'm just running it so that everything works fine and all our libraries will also get in. Cannot Python app.py. Okay, I have to probably go to my chatbot folder. cd chatbot. So now I'll clear my screen. Python app.py. Sorry. From Streamlit as st. Okay, import Streamlit as st. I have to write. So that is the reason it was coming all these errors. Now let's see if everything is working fine. Langchain core. So here you can probably see that there is a spelling mistake. Okay, but I'm just going to keep all the errors like this so that you'll be able to see it. Python app.py. If everything works fine. Dot output parser. Okay, p capital. So I think my suggestion box is not working well, and that is the reason. Now everything is working fine. Here you can see that I'm not getting any error. So let's start our coding and let's continue it. Okay, so we have imported all these things right now. Now, as I suggested, guys, since we are going to use three environment variables, one is the OpenAI API key, Langchain API key, and along with that, I will also make sure that the tracing to capture all the monitoring results, I will keep this three environment variable. One is OpenAI API key, Langchain tracing version 2, and Langchain API key. So Langchain API key will actually help us to know that where the entire monitoring results needs to be stored, right? So that dashboard, you'll be able to see all the monitoring results will be over here, and tracing we have kept it as true. So it is automatically going to do the tracing with respect to any code that I write. And this is not just with respect to paid APIs, with open source LLM also, you'll be able to do it. Now this is the second step that I've actually done. Now let's go ahead and define my prompt template. Simple. So here I'm going to write my prompt template. Okay. Prompt template. So here I'm going to define prompt is equal to chat prompt template dot, okay, from _ messages. Okay. And here I'm going to define my prompt template in the form of list. The first thing that with respect to my prompt template that I'm going to give is nothing but system, and system here I say that you are a helpful assistant. Please respond to the queries. Okay. Please respond to the questions or queries. Please respond to the user queries. Okay. whatever queries that I'm going to specifically ask. A simple prompt that you can probably see over here. The next statement after this is what? So this will be my next. See, if I'm giving a system prompt, I also have to give a user prompt, right? User prompt will be whatever question I ask. So this will be user, and here I will define something like question colon question. I can also give context if I want, but right now I'll just give it as a question. A simple chatbot application so that you'll be able to start your practice of creating all these chatbots. So now I will go ahead and define my Streamlit framework. Okay. See, the learning process will be in such a way that I will try to create more projects and use functionalities that are there, right? And in this way, you'll be able to work it in an amazing way. Okay. So here I'm going to basically write st.title Langchain demo with the OpenAI API, st.text_input, search the text topic you want. Okay. Now let us go ahead and call my OpenAI LLMs. Okay. OpenAI LLM. So here I'm going to basically write LLM, and whenever we use OpenAI API, so it will be nothing but chat OpenAI. And here I'm going to give my model name. The model name will be nothing but GPT 3.5 Turbo. So I'm going to use Turbo because the cost is less for this. I've put $5 in my OpenAI account. Okay, just to teach you. So please make sure that you support so that I will be able to explore all these tools and create videos for all of you. Okay. And finally, my output parser. See, always remember LangChain provides you features that you can attach in the form of chain, right? So here, three main things we have created. One is the chat prompt template. Next one is the LLM, and next one is the output parser. Obviously, if this is the first thing that we require. After this, we integrate with our LLM, and then finally we get our output. So string output parser is responsible in getting the output itself. Finally, chain is equal to, we will just combine all these things. So here I'm going to write prompt, LLM, and then finally my output parser, right? I will show you going forward how we can customize this entire output parser and all. And finally, if I write if input underscore text colon. Now, whenever I write any input and probably press enter, then I should be able to get this output. So st.write, and here I'm going to just write chain.invoke, and finally I give my input as question, and that input is assigned to my input text, right? So this is what we are going to basically do, right? st.write. Now this is what we are doing, a simple chatbot application, but along with this, we have implemented this feature is specifically for LangSmith tracking. Okay, this will be amazing to use. Okay, and this is the recent updates that are there. So whatever code I'm writing will be applicable going forward in various things that are probably going to come up. Okay, now let's go ahead and run this. So in order to run it, you will just need to write nothing but Streamlit run app.py. Okay. Oops, there is an error, app.py. And here I'll do allow access. Okay. So right now you'll be able to see over here LangChain series test LLM, but my project name was project 1. Okay. So now if I go ahead and hit hey hi, okay, and just press enter, you'll be able to see that we'll be getting this information over here. And here you can see my project something. Let me reload it. Tutorial 1, right? So this is the first request that is already been hit. And here you'll be able to see your runnable sequence, chat prompt template, right? All the chat prompt template, output message, your helpful assistance, please response to the user queries, right? Along with this, you will be seeing chat OpenAI API. And with respect to this, what was the cost? Everything you are able to track. So $0.00027 is the cost that actually took with respect to this. And finally, my string output parser. How can you assist today with respect to this output parser? It is just going to give me the response clearly. Now, when I develop my own custom output parser, I'll be able to track everything. So here, what you are able to do, you are able to monitor each and everything that is there, right? All the requests that is probably coming up. Okay. So provide me a Python code to swap two numbers. Okay. So once I execute this, And here you'll be able to see that I'm able to get the output and answer. Everything is over here. And for this, you'll be able to see the cost will be little bit high. Okay. If you don't agree with me, or let's see, with respect to tutorial 1, the second request that I've actually got 4.80 seconds. Yes, it took a little bit more time. And here the cost was 0.000211. So it is based on the token size, right? For every token, it is bearing some kind of cost. Perfect. This was the first part of this particular tutorial. Now let's go to the second part. The second part is more about making you understand that how you can call open source LLMs in your local itself and how you can actually use it. So for this, first of all, I will go ahead and download Ollama. Okay. Ollama is an amazing thing because you'll be able to run all the large language models locally. The best thing about Ollama is that it automatically does the compression, and probably in your local you'll be able to run it. Let's say if you have 16 GB RAM, you will just have to wait for some amount of time to get the response. But Llama 2 and Code Llama, you can specifically use it over here. All the open source LLM models, and it supports a lot of open source LLM models. And yes, in Langchain ecosystem, the integration has also been provided over here. So what I'm actually going to do over here is that I'll show you. First of all, just go ahead and download it. This is available both in Mac, Linux and Windows, wherever you want. Just download it. After you downloaded it, what you really need to do is just go ahead and install it. It is a simple exe file for Windows, MSI file for Mac OS, and then Linux is a different version. So you just need to double click it and start installing it. Once you install it, here somewhere in the bottom, this Ollama will be start running. Okay. Now once Ollama installation is done, now what I will do over here, I will create another file inside my chatbot. Okay. And create another file, local llama. Okay, local llama.py. Now local llama.py, what we are going to basically do over here is that with respect to the local llama, I will first of all go ahead and import some of the libraries. See, code will be almost same, right? There also I'll be using chat open API, chat prompt template, string output parser. So I'll copy the same thing over here. I'll paste it over here. Now, along with this, what I'm going to do, I have to import Ollama, right? Because that is the reason why we will be able to download all these specific models. Okay. So Langchain community.llm. See, over here, whenever we need to do the third-party integration, so that will be available inside Langchain community. Okay. So Ollama is third-party configurations. Let's say you are using some vector embeddings, that is also third-party. So everything will be available over here. Okay. Now this is done. So Langchain _community.llms import Ollama, and then we have this output parser, string output parser, core .prompts, that is nothing but chat prompt template, and everything is there. Okay. Now let's go ahead and write import Streamlit as st. So I'm going to use the Streamlit over here along with this import OS. And not only that, we will also go ahead and import from .env import load underscore dot env. Okay. Now we'll initialize it, load underscore dot env. Okay. Once we initialize all this random environment variables, as usual, I will be importing these three things. Now see, in my previous code, when I was using OpenAI API, prompt template, we have written it over here, right? Same prompt template, we'll also write it over here, because we just need to repeat it. Because the main thing is that you really need to understand how, with the help of Ollama, I can call any open source models. Okay. So here it is. And then finally, you'll be able to see where is my code to call my OpenAI LLMs that we are going to see over here. So this is done now. Streamlit framework also, I will try to call it over here. Okay, it's more about copy paste, the same thing that we have actually implemented. And then you will also be seeing this is the code that we are going to implement it. Okay, but here we are calling chat OpenAI. Okay, I specifically don't want chat OpenAI. Instead, I will be calling Ollama. Okay, so Ollama, whatever library we have imported. So Ollama. Okay, and then here we are specifically going to call Llama 2. Okay. Now, before calling any models, now which all model are specifically supported? If you go ahead and see in the GitHub, right, of Ollama, you'll be seeing the list of everything, every libraries that it supports, like Llama 2, Mistral, Dolphin 5, 2 Neural Chat, Code Llama, all are mostly open source. Like Gemma is also there. But before calling this, what you really need to do is that just go to your command prompt. Let's say that I want to use Gamma model. Okay. So what I have to do, or I have to use Llama model, right? So in order to do this, I have to just write Ollama run whatever model name, because initially it needs to download it, right? This will get downloaded from some open source, some GitHub. It can be Hugging Face, somewhere, right? Some location they will be there. We have to download that entire model. So let's say that I want to go ahead and write Ollama run Gamma. So this, what will happen? It will pull the entire Gamma model, right? Wherever it is. So here you can see pulling will basically happen. Now this is right now 5.2 GB, right? For the first instance, you really need to do it. Now, since I am writing the code with respect to Llama 2, I've already downloaded that model. So that is the reason I'm showing you another example over here. Ollama run Gamma. Now, once this entire downloading happens, then only I'll be able to use the Gamma model in my local with the help of Ollama. So I hope you have got an idea about it. Now, what I'm actually going to do, so here I've called Ollama model Llama 2. Okay. Then again, output parser is this, and I'm combining prompt, LLM on output parser, and everything will be almost same. And that is the most amazing thing about Langchain. The code will be only generic. Now, only you need to replace OpenAI or paid or open source. It is up to you. Again, I'm saying you guys, the system that I'm currently working in has a 64 GB RAM. It has NVIDIA Titan RTX, which was gifted by NVIDIA itself. So with respect to this amazing system, I will be able to run very, very much quickly. That is what I feel. So let's go ahead and run it. So here what I'm actually going to do, I'm going to write Python. So it is Streamlit. So Streamlit run local llama.py. So once I execute it, here you will be able to see now. Now, instead of OpenAI API, I should had, okay, no module name, Langchain community. Let's see, where is Langchain community? Okay. I have to also make sure that in my requirement.txt, I go ahead and use this Langchain community, and I need to import this library since I need to do that. And that is the reason I'm getting an error. So if I go ahead and write pip install -r requirement.txt, oops, cd ... Okay, now if I go ahead and write pip install -r requirement.txt, so here you will be able to see my requirement.txt will get installed. This Langchain community will get installed. And once I'm done with this, then I can probably go ahead and run my code. Okay, so this will take some amount of time. So if you are liking this video, please make sure that you hit like. There are many things that are probably going to come up, and it will be quite amazing when you learn all these things. Okay, so once this is done, then what will happen is that we can, and you can use any model, up to you. Okay, and I don't want this OpenAI key also, only this two information I specifically want. I'll be able to track all these things. Okay, and later on I'll also show you how you can create this in the form of APIs. And again, it is some time, it will take this, but let me know how do you think all these tutorials are. Langchain, I see a lot of purpose for this particular library. It is quite amazing that people are doing, the company is doing amazingly well in this open source world, and it is developing multiple things over there. So now I will go ahead and write cd chatbot. I will go inside my chatbot, and then I will run this Python local llama.py. Now once I execute this, now I don't think so it should be an error. Okay, it should be Streamlit. Come on. Streamlit run local llama. Oops, local llama.py. Not Python run, Streamlit run. Now here you have, again, I'll be getting OpenAI text over here. Let me change this also so that I can make it perfect. With llama 2. Okay. So I've executed it, saved it. I will rerun it. I'll say, hey, hi. So once I execute it, you'll be seeing that it'll take some amount of time in my system, even though I have a 64 GB RAM, but I'll get the output over here. So assistant says, hello, how can I help you today? Now, if I probably go ahead with respect to this dashboard, let's see where it is. So now tutorial 1, you'll be able to see that this will increase. Okay. There will be one more over here, right? So I've reloaded this page. Okay. And you'll be able to see it. Okay. You'll be able to see the new Ollama request. See, hey, hi, 4.89 second, token 39, but there is no charges because it is an open source model, right? So here you'll be able to see, if I extend this, there you'll be able to see chat prompt template, Ollama is over here. Now this OLlama is specifically calling Llama 2 over there and whatever open source libraries that you specifically want. Just to call this, it is very much simple. You have to just go into the GitHub and download any model first of all, just by writing OLlama run that particular model name. And once it is downloaded, it is good that you can probably go ahead with and use it. Okay. Now I will say provide me a Python code to swap two numbers. Okay. If you want more coding well chatbot, you can directly use CodeLlama if you want. Okay. So here you can see all the examples are there and this was quite fast, right? So this is good, so if you have the right kind of things, so here you can see 4 seconds it has probably taken. Okay. OLlama is over here. All the information is probably over here, prompt and completion and all, right? Hello guys. So we are going to continue the LangChain series. Already in our previous video, we have already seen how to create chatbots with the help of both OpenAI API and open source LLM models like Llama 2. We have also seen what is the use of OLlama, how you can run all these open source model locally in your system. And along with this, we also created multiple end-to-end projects using both of them. Now, what we are going to do in this specific video, one more step, which is very much important for our production grade deployment, that is creating APIs, for all this kind of LLM models. We will be able to create APIs. And through this, you will also be able to do the deployment in a very efficient manner. Now, how we are going to create this specific APIs, there is a very important component which is called as LangServe in LangChain. We are going to use that. Along with this, we are going to use Fast API. And not only that, we'll also create a Swagger UI, which is already provided by LangChain, the LangServe library that we are specifically going to use. Now, it is important, guys, you know this specific step, because tomorrow, if you are also developing any application, you obviously want to do the deployment for that particular application. So creating the entire API for this application will be the first task that will be required. So yes, let's continue. Let's go ahead and discuss this entire thing. First of all, how we are going to go ahead. First of all, I'm going to show you the theoretical intuition, how we are going to develop it, and then we will start the coding part. So let me quickly go ahead and share my screen. What we are actually going to do over here, you have seen that I've written APIs for deployment. Okay. So if I consider this diagram, this is the most simplistic diagram that I could draw. Okay. Now let's consider, see, at the end of the day in companies, right, there will be different applications. These applications are obviously created by software engineers, right? It can be a mobile app, it can be a desktop app, web app and all. Now for this particular app, if I want to integrate any foundation model or any fine-tuned foundation model like LLMs and all, so what I really need to do is that I need to integrate this with the form of APIs. At the end of the day, see what we are going to do over here. This side is my LLM models itself, right? It can be a fine-tuned LLM models. It can be a foundation model. I want to use those functionality along with my web app or a mobile app. So what we are doing is over here is that we will create this specific APIs. Now this APIs will be having routes, okay? Routes. And this routes will be responsible whether we have to probably interact with OpenAI or whether we have to interact with other LLM model like Cloudy3 or Llama 2 open source model. So any number of LLM models, whether it is open source or whether it is paid API models specifically for LLM, we can definitely use it. Now this is what we are going to do in this video. We will create this separately, we will create this separately, and at the end of the day, I'll also give you an option through routes how you can integrate with multiple LLM models, right? So I hope you have got an idea with respect to this, and any number of LLM models it may probably come, you can probably integrate it. At the end of the day, whichever model is suitable for you, you can use for different functionality. And the reason why I'm making this video, understand one thing, guys, because in LLMs also you have different performance metrics. Some model is very good at some performance metrics over there, like MMLU, other metrics are definitely there. So this is an option where we can use multiple LLM models. Now what we are going to do, quickly I will go ahead and open my code document. So in my previous video, already you have seen I had actually developed till here, right? I have basically, if you see over here, we have created this first folder that is chatbot. And inside this chatbot, we had created app.py, then local llama.py, right? We did this entire thing. And as I said, every tutorial, I'll keep on creating folders and developing our own project over here. Now let's go ahead and create my second folder, and this time this will be APIs. Okay, so I'll just go ahead and write something like API. Okay, now with respect to this API, as I said, whatever we do with this local llama or app.py, right, over here I've used OpenAI API key, here I've used open source models. So we'll try to integrate both of them in the form of routes, okay, so that we'll be able to create an API. So let me quickly go ahead and write over here app.py. So one will be my app.py, which will be responsible in creating all the APIs. The second one will specifically be my client.py. Now client.py in this specific diagram is just imagine like this one, web app or mobile app, because we are going to integrate this APIs with this mobile app or web app. Okay. So quickly, let's do this. First of all, I will go ahead and start writing the code in app.py. Before I go ahead, we have to make sure that we need to update all the requirement.txt. Almost all the libraries I've installed it, but I'm going to install more 3 libraries. One is LangServe, Fast API, and UVCon. Okay, since I'm going to create my entire Swagger documentation of API using Fast API, right? So all these 3 libraries I'll be using it. So first of all, I will go ahead and install all these libraries. That will do once we run the code. Right now, let's go ahead and write my app.py code. Okay. Now, as usual, first of all, let me just open my terminal. Okay. And let me do one thing with respect to the terminal. I will go ahead and write pip install -r requirement.txt. Okay, first of all, I need to just write cd ... Okay, then I'll clear the screen and then go ahead and write pip install -r requirement.txt. Now here you'll be able to see that my entire installation will start taking place. And here the other 3 packages that I have actually written, right, LangServe and all, that will get particularly installed. Okay. Now till then installation is basically going on. Let me go ahead and write my code. So I will write from Fast API import Fast API. Okay. So this is the first library that I'm going to import. Along with this, I have to also make sure that I create or I import my chat prompt template. So from Langchain, since we are going to create an entire APIs in this, okay, dot prompts import chat prompt template, right? So this is done. Then from Langchain dot chat underscore models import chat OpenAI. So this is the next one, since I need to make sure that I need to create a chat application. So that is the reason why I'm using this chat models. Okay. This is the next library that I'll be going ahead and importing. Along with this, I will also use LangServe, which will be responsible in creating my entire APIs, right? So from LangServe import add routes. Okay. So through this, I will be able to add all the routes over there, right? Whatever routes. Suppose one route will be that I need to interact with my OpenAI API. One route will be to interact with the Llama 2 and all. So based on that, I will go ahead and import this. Next thing is import UVCon. Okay. UVCon will be required over here. Oops. Okay. Next is import OS. See, I can probably enable my GitHub Copilot and I can probably write the code, but I don't think so. That will be a better way. I usually use this AI tool, which is called as Blackbox, so that it will help me to write my code faster, and it also explains about the code. So I'll probably create another video about it. Okay. So how to basically use this. Then one more thing that I really want to import over here is my Ollama. So from Langchain underscore community dot LLMs import Ollama. Okay. So this is done. All the libraries that is specifically required by my code, I have actually written that. Okay. And these are all the things that I will require to create my OpenAI API. Now this is done. Now what I'm actually going to do over here is that I'm just going to write os.environment, and first of all I will initialize my OpenAI API key. So I will write OpenAI underscore API underscore key. Okay. And this specifically, I will load it from os.getEnv, and then I will go ahead and write open AI underscore API underscore key. Okay. So this is the first thing that we really need to do. Before I do this, I will just go back to my app.py and I will just initialize this. Okay. Load underscore .env. Let me quickly copy this entire thing and paste it over here. And I will initialize this load underscore .env. Okay. So this will actually help me to initialize all my environment variable. Perfect. I've also loaded my OpenAI API key. Now let's start this fast API. Now in order to create the fast API, I have to create an app. Here I've given title Langchain server, version 1.0, and the third information I basically want is the description. Now after this, I can use this app and I can keep on adding my routes. Okay. So what I will do, add underscore routes, and this routes is basically to add all the routes over there, right? So the first time when we are adding this particular routes, you have to make sure that I give all the information, like whether I'm going up with my app. Let's say I go with this chat OpenAI API, chat OpenAI. Okay. And the third information that I will probably give is my path. So this is my one of my route. You can just consider this OpenAI route, and this is my model that I will specifically be using. So this is just one way how you can actually add route. Okay. But let me just add some more things, because see, at the end of the day, when we created our first application, we used to combine prompt, LLM and output parser in this specific way. So what we will do over here is that when we are creating routes, we also need to make sure that we add all the routes in such a way that I also integrate my prompt template with it. Okay. So here I'm going to say model is equal to chat OpenAI, and I'm going to initialize this particular model. And then let me go ahead and create my other model also. See, OLlama, I will just use my Llama 2. Okay, so this model also I need to basically create it or call it. Okay, because I want to use multiple models. So here I'm going to write LLM and here OLlama, and this will basically be my model is equal to Llama 2. Okay, so I'm going to use the Llama 2 model. So this is my one model over here. This is my another model over here. Okay. Now let me quickly go ahead and create my prompt one. So my prompt one will be my chat prompt template dot from underscore template. Okay. And here I'm going to basically give one chat prompt. Okay. Let's say one of my interaction, I want to use OpenAI API. For OpenAI API, let's say I want to create an essay. So I'll say, write me an essay about a specific topic. That topic I will be giving it. Okay. About some topic. Okay. Okay. Around with 200 words or with 100 words. Okay. So this is my first prompt template. Okay. I'm saying this will be my prompt template. Write me an essay about whatever topic I give with 100 words. Okay. Something like this. So this, let's go ahead and write this. This is my first prompt template. Then I will create my second prompt template. Okay. This is important. Just hear me out. Okay. And this prompt template will be responsible in interacting with my open source model. So let me say, write me a poem. I'll say, write me a poem about this specific topic with 100 words. So in short, this first prompt template will be interacting with this model, that is chat OpenAI API. Prompt 2 will be interacting with LLM model. Okay, whatever LLM model I've written over here, that is Llama 2. Now let me go ahead and add this routes. So here I'll say add routes. Okay, and again as usual I will write app. Now here you see I will be combining prompt or model, right? Model will be chat OpenAI API, and you know this prompt 1 is specifically for my chat OpenAI API, right? Then I will also give the route path. So my path will be something like this. Okay. And this will be my API, right? So here say, let's say I'll write /essay. That basically means this path is responsible in interacting with the OpenAI API. and this is denoted by /sa. So that API URL that you will be getting will be ending with /sa. Okay. The other route, and I can keep on adding any number of routes as you want. So another route will be like with prompt2. Okay. And here I'm going to basically use my LLM, and let me just go ahead and write this as /poem. Okay. /poem. So this is my another route. This is my another route. Okay. And finally, I've created two APIs in short. And now here I will write if underscore underscore name underscore underscore is double equal to underscore underscore main underscore underscore. Right. Now what we are going to do over here, this is the starting of the application. I will say uvcon dot run, and here I'm going to use my app comma host will specifically be my local host. See, here I'm giving you the local host. This application you can run it in any server that you want, right? So that is the reason why I'm saying this is the first step towards building that production grade application. Okay, and the port number will be 8000. Perfect. So this is done. I think it looks really, really amazing. We have written the complete code over here. And this is my entire app.py with all the APIs. So that basically means if I see the diagram over here, this APIs part I have actually created. Routes along with prompt template I have created. And I have used two APIs. One is OpenAI and one is Llama 2. Two routes I have specifically used. Now my time is to basically create this web app and mobile app. Okay, and here I will just try to create a simple web app. The reason why I'm creating this simple web app, because it will be able to interact with this. Okay. Now what I will do, let's go ahead and run this and see whether everything is running fine or not. Okay. So here what I will do, I will go to my CD, which folder this is. This is basically my API folder. Okay. So CD API, port. Let's me just write it. Ready? Port. Okay. Done. CD. I'll save this CD API. Okay. And then here I'm going to write Python app.py. Okay. Now, once I execute this from Langchain.prompts, just let me see the documentation, whether it is correct or not. It should be prompts. Okay. So a small issue over here. It should be prompts. Now let me just go ahead and execute it. Now I think it should work fine. So here you can see import error SSE starlet. Okay, so this is one of the dependency that is probably coming up. I will quickly go ahead and update my requirement.txt. Okay, and let me do one thing. Just let me write pip install this particular application. Okay, so I will go ahead and write pip install control V. Pip install and SSE starlet. Okay, so once this installation will probably happen, I think now we'll not get an error. Now if I write python app.py, it should run, I guess. So it is now running. Okay, so let's go ahead and open this local host. Now here you can see I'm getting details not found, but if you really want to see that entire APIs that is basically created, you can just write /docs. Now here you can see your entire Langchain server. See, I've created OpenAI, input schema, everything is given. SA is also there, poem is also there and all, right? So all the APIs is almost created. See, here you can see what is the input, what is the output schema, what is basically required. Everything is probably given over here. And this is basically called as a Swagger UI documentation. Okay, the entire Swagger UI documentation is done. Now, perfect. Your APIs part is basically created. Now, how do we interact with this APIs? That is the most important part. So for that, what we are going to basically do, I'm going to let this terminal be hidden over here. I'm going to create my client.py. Okay. Now, with respect to the client.py, what we are going to do, and let me do one thing till then. I will go ahead and disable this extension. Okay, because I don't want this extension to disturb things. Okay, disable. Perfect. I will show you this extension. It is a very powerful extension. Okay. Now this client.py is my app. It can be my app. Okay. So first of all, what I'll do, I will go ahead and import requests. Okay. After importing request, I'm going to write import Streamlit as st. Okay, so two libraries I'm going to import, request and Streamlit. Understand, I'm creating a web app. I can create a front end that will interact with the API. Okay, so here first of all I will write two definition or two important function. One is get underscore OpenAI underscore response, and here I'm going to basically go ahead and write my input underscore text. Okay, here I will probably use this request object and create my response. Now in order to create the response, in order to call the API, how do I do it? So here I'm going to write request dot post, and how to basically call it. So first of all I need to give the URL. Understand, we are already running this URL, right? This entire local host. If you probably see over here, everything is running over here, right? If you see this, okay, if you probably see this and try to see this entire URL, okay, you can directly see that in order to call these APIs, I will be using a URL that is already provided by this particular Swagger UI. That is nothing but, let's say I want to call the SA URL, okay. Now in order to call the SA URL, which is using the OpenAI API, here you can see HTTP localhost 8000 SA/invoke. So this is my entire API URL, which will be responsible in calling this. And here we also know that we need to give one input. So what I will do, I will go ahead and write over here as JSON is equal to, and in the form of JSON, I will give one of my input. So input colon, okay. And here I will write topic. Why topic? Because see here what we are given over here, if you see over here, topic is there, right? Now this topic will be nothing but whatever input text I am giving to this particular function, that same input text will be visible over here. Okay. So this is what we have actually done over here, right? So input topic colon input underscore text. So this is what is the input I will give, and it will hit this particular URL along with this particular input post. Okay. And then finally I get my response. Now what I will do, I will go ahead and take this response, convert into a JSON, and it has a key dictionary value pairs, where my output content will be present inside this variable called as output. And one more thing that I require is basically content. Okay. So inside this key, my entire response will be available. The next thing that I am actually going to do is similar with the help of OLlama response. And here we are going to use Llama 2. So get OLlama response input text, again request.post. Now instead of using this /SA/invoke, we are going to use /poem/invoke. Why /poem/invoke? Because /poem will be responsible in interacting with Llama 2. Okay. And then I get my JSON. Again, I get my response. Here I'm writing response.json of output. Okay. So these are my two functions that I've actually created to get the response. Now let me do one thing. Now let me go ahead and create my Streamlit framework. Very simple now. Now from here, everything will be simple. Okay. So st.title, this is there. I've created two text box. One is input text and one is input text one. First text box, I'm saying write an essay on whatever topic. The second text box, I'm writing write a poem of any other topic. Okay. So first one will be interacting with the OpenAI application. The second one will be interacting with Llama 2. Okay. And finally, I'm going to call this particular two function that I've created. If input.text, if I write any text in the first time, then it should basically interact with the OpenAI response. Whatever response I'm getting, it will display it over here. If input text 1, I'll just call the OLlama response, which is interacting with the Llama 2 in this particular URL. Okay. And then I will get over here the output. So this is my entire application which is interacting with the API, which is already running over here, right? Now with respect to this client.py, what I am actually going to do, I'm going to create another command prompt and let me run this. Okay. So here I will say conda deactivate, and I will say conda activate VNV. Okay. And let me just go ahead and run this. Now see, Python client.py. Okay. Okay. Sorry. It should be Streamlit. Run client.py. Okay. So this is my client side. Okay. File does not exist. Okay. Oh, I will say CD and I will go to my folder that is API. Now let me go ahead and write streamlit run client.py. Now see this. This is my Swagger UI. The APIs is running over here, and this is my front end application, which is basically now it will interact with this APIs. Okay. Now, if I write the first one, the first anything in the first text box, this is going to interact with the OpenAI API. So I'll say write an essay on machine learning. Okay. So here you can see name get OpenAI response is not defined. Why this is the error? Let's see. OpenAI response. Oops, just a second. This function name does not match. And this also Olama response does not match or what? Okay, now I think it should work. Let's reload it. Okay. Now you can see automatically machine learning is a powerful technology that enables computer this. So the first text box is interacting with the OpenAI API. Write a poem on machine learning. Let's say if I give the same thing, if I execute it, now this is going to interact with the Llama 2. So machine learning is a field of art that allows computers to make decisions. Oh, still running. Sorry. This was the first response that I got from there. Okay, it's running, I guess. Let me reload it. Write a poem on machine learning. Okay. And I can also write my own custom prompt if I want. Everybody, I was thinking that we could make a bit of interesting by adding some extra challenges. So what do you say? Or something is given. Okay. And if I probably see over here with respect to the prompt input text 1, this is also going over here. This is my input text. Okay, perfect. So everything works fine. And here you'll be able to see, write a poem about this particular topic with for a 5-year child. Okay, so now let's see. I'll just try to change the prompt and see whether it is working fine or not. So this has got reloaded it. Let's see whether this is reloaded or not. Now, if I go ahead and reload this, write a poem on unicorn. Okay, I'm just writing something. Unicorn. I think it should be able to give the poem. Shimmering coat in various colors. Yeah, 100 words that describe a unicorn. Okay, something information is basically coming, and this is basically interacting with the entire Llama 2. Hello guys, we are going to continue the LangChain series, and in this specific videos and in the series of upcoming videos, we are going to discuss about RAG pipeline. Now RAG, the full form is retrieval augmented generation. One of the very important use cases you may probably be solving when you specifically use LLM models. And most of the use cases right now in companies are demanding this kind of skill sets, where you can actually develop RAG. Let's say you have a set of documents and you should be able to query that specific documents and get the result quickly. If you have different kind of files, let it be a README file, a text file, a different data source file, you should be able to read it, convert that into a vectors and able to retrieve any queries specifically from those kind of data sources. So as I said, we will be implementing this completely from scratch, from basic to advanced. In this specific videos, we'll understand the entire architecture and then we will do a lot of practical intuitions. Okay. So in any RAG pipeline, these are the major components that will probably exist. So the first component is specifically called as load data source. Now, whenever we say load data source, initially we may have, RAG is all about querying from a different data source altogether, right? So we may be having files that may be having PDF, it can be a MD file, README file, it can be a Excel file, it can be a TXT file, it can be a database file, it can be different files altogether, right? And in the first step that we see over here, it is basically called as load source data. This step is also called as data ingestion, okay? Data ingestion. Now in LangChain, the most amazing thing is that it definitely have a lot of different kind of data ingestion tools which will be able to load the data in various manner. So in our current video, we are going to implement each and every of this component from data ingestion till the query vector store. Okay. Then after ingesting the data, you can probably do load, you can transform and you can embed. Okay. We will discuss about this, what exactly is load, transform and embed. Specifically, when we do loading, that is nothing but we are reading from a specific data source. Then we perform some type of feature engineering over here if we want, like in transform stage. Here, the data, the complete data will be broken into smaller chunks. Okay. Now, why do we divide this data into smaller chunks? It is very much important to understand, because whatever LLM models we specifically use, right, is definitely has some kind of context size, right? So based on this context size, it is always a good way to basically convert this entire data, which can be of many number of PDFs. It can be many number of pages in this specific PDF. We will try to divide this particular thing into chunks of data. So this is also what we're going to see in the practical way. Then finally, we go ahead with embeddings. Embeddings basically means how we can convert all these chunks into vectors. Okay, how we can actually use vectors in order to probably convert these chunks, right? And finally, all these vectors will be further stored in some kind of vector stored database. Okay, so it can be a database over here, and the main reason of this specific database is that we will be able to query this particular database in an efficient manner, right, with respect to any query that we have, right? So whatever vectors are basically stored, if I have a query, if I hit the query on this particular database, I should be able to get the result based on the context of the query. So this is the entire RAG pipeline that we specifically use. In the upcoming series of videos, we are going to use different vector databases in different clouds also. Okay, so right now we will try to implement all these things that you can actually see in front of you, and we will follow this entire architecture. So let me quickly open my VS Code, and once I probably start my VS Code, I will continue with respect to the same thing that I have actually used, right? All the projects that I've actually created. As I said, that all the things will be given in the description of this particular video with respect to the GitHub link. Okay. Now I've created a folder which is called as RAG. Inside this, I will create one IPYNB file. Okay. Initially, we'll go with IPYNB file, and then later on we'll try to create an end-to-end project. Okay. So here I will say simple rag.ipynb. Since we are doing it completely from basics, it is always good that we try to do it completely from basic itself, right? So this is the thing. So first of all, I will go ahead and see whether in my terminal, whether I have that IPy kernel installed or not. Okay. So I will go ahead and write pip install IPy kernel. IPy kernel is specifically used to install the Jupyter Notebook kernels itself, right? So once I probably install this, you will be able to see that this installation will take place, and I think it is already satisfied. So it is good enough. We can probably go ahead and start the coding over here. Then I will go ahead and select my kernel, and it is nothing but 3.10.0, right? This is what is the environment that I have created. Now, if I go ahead and execute something, so it is giving me some kind of error. Okay, so perfect. Now what I'm actually going to do, I can see that there is some kind of message over here. I will just try to disable this. I've already uninstalled this extension so that it will not give us any disturbance. So let me do one thing. Let me just open over here for you, and here I will open this particular folder, and then I will go ahead and close this. Okay, close window. Okay, and now let me quickly open the VS Code again. And here is my entire project. We will just try to execute it once again. Okay, perfect. So that I don't have any disturbance with respect to that. Okay, now perfect. Now this is done. Now let's go ahead and start our coding. Initially, I will try to show you multiple data ingestion steps. Okay, so data ingestion basically means, let's say I want to read from a text file, I want to read from a PDF file, I want to read from a web page. How can I actually do it? Okay, so all those things we'll start to discuss. So first of all, I will go ahead and import from Langchain _ community .document loaders. Now document loaders has all the techniques. Specifically, if you want to load let's say a PDF, you want to load a Excel file, you want to load a TXT file. So over here, all the libraries will be present. So from Langchain _ community .document loaders. Until then, I will just close this terminal because I will not require over here. Then the first one that I'm actually going to discuss is about text loader itself. Now over here, what I'm actually going to do, I'm going to create a loader is equal to text loader. And after creating this text loader, here I'm going to give a text file, okay, speech.txt. So we'll just go ahead and see whether we have the speech.txt file or not. No, I don't have it. So let me go ahead and create one speech.txt file, okay. And with respect to this particular file, what I am actually going to do, I'm going to put some content. So I have already have that content. Let me just quickly copy and paste it. This is one of the most famous speech that is available in some history. It has been taken over here. So I just Googled it and I bought this particular speech over here and saved it in speech.txt. Okay. Then what I will do, I will go over here and read this speech.txt. Okay. Now, just by using this text loader, what will happen is that you'll be able to read the speech.txt. Then I will use loader.load. And here I'm going to specifically convert this entire thing into text documents. Okay. Once I write loader.load, that basically means it is going to just convert this into a text documents. And this finally you'll be able to see my text documents. And I will go ahead and execute it. So here you'll be able to see that once it is reading the specific speech, it has the entire text document. Now it is becoming so easy just to read the txt file. Okay. Now the next thing that I'm going to specifically do is that since I'm also going to use OpenAI API keys, or I'm also going to use Ollama embeddings or Ollama model. So what I can do is that I will just go ahead and import OS. The next thing that I will go ahead and do is load underscore dot env. Okay. So load underscore dot env. So for this, I'm also going to import from dot env. Import load underscore dot env. Okay. Now why I'm doing this, so that I will be able to call all my environment variables, and in one of the environment variables I also have my OpenAI API key. So now I will go ahead and write os dot environment, and here I'm going to use my OpenAI underscore API underscore key. And here I'm just going to use os.getEnv. And here again, I'm going to use my OpenAPI key. So this is basically going to call the OpenAPI key from the environment variable. Now a very important step altogether over here, guys. Now is the main term that we will be starting to see some more data ingestion techniques. So one more data ingestion technique is directly reading from the web-based loader, you can basically say. Okay. And for this, again, I will be importing. Understand, any document loader will be available in this specific library itself. And instead of writing text loader, we will be using web-based loader. Okay. Now, along with this, I will also import BS4, that is Beautiful Soup 4. So for that also, what I will do, I will just import over here in my requirement.txt BS4, so that whenever I execute this, it should be able to run. Okay. Now, in order to do something like this, load, chunk, and index the content of the page, HTML page, right? Or any web page. So here I will create a loader, and this will be equal to web-based loader. And here I'm going to give two important parameters. One is the web path. So web underscore paths, okay, is equal to, and here I will give the URL. So let me just take one URL from the GitHub IO page that is also available in the documentation of Langchain. So this is what is the page over here. What I will do is that quickly I will open a browser and show it to you how this page looks like. Okay. So if I execute this over here, you'll be able to see that. Just a second. Okay, perfect. So here you are able to see that. Just a second. Is this the same page? Yes, it is the same page. And I will be opening this. Okay, perfect. So this is the page that you will be able to see over here. And I want to probably read this entire page and use it as a RAG system itself, right? So in order to read this entire page, I can just take this URL and use this web loader library. So here, if you see, I'm using this web-based loader library, and I'm giving the first parameter, that is the web path. Okay. The second parameter that we can specifically give is our arguments, right? So here I will write bs dot underscore kwargs. Okay, so this is the second parameter. I'm just seeing the documentation, and we will give the next argument in the form of dictionaries. The first is parse underscore only. Okay, and then here I'm basically going to use my bs4, that is a beautiful soup trainer. Okay, soup strainer. Okay, yeah, soup strainer. So this is the first parameter that I will be specifically giving, and understand why this is required, because here this soup strainer, and since we are using beautiful soup over here, we really need to give the classes that it needs to read from that particular page. Okay, and here what all classes are there, let's go ahead and see this. Okay, so if I probably see over here, and if I do just inspect element, okay, so here you can see post title is there. Then you have something like post content, where all the content is basically available. So let us take this one as my first one. Okay, so I will just go ahead and execute this, and here you will be able to see that this will basically be my post title, and here you have the post underscore content, and third one that I also want to take is post underscore header, because header will also have some information over here, right? So this is done. You'll be able to see that it looks absolutely fine, and here with respect to this we have also created this entire loader, and here I will use a comma so that this is basically my argument over here, right? So once we do this, then let's see whether it will execute or not. bs4 is not found. As I said that bs4 is not there. So let me do one thing quickly. Let me open my command prompt and do the pip install requirement.txt. Okay, so here I will go ahead and write pip install -r requirement.txt and execute it over here. You will be able to see now bs4 will also get installed, and once it is getting installed, it is completed, it is good to go. Now if we go ahead and execute it, I think it should work perfect. Now loader is there. Now what we are going to do over here is that again write loader.load, and finally I will be able to get in the form of text documents, text underscore documents. Okay, documents, and here is my text document. So perhaps you meant this one. Let's see. So guys, there was one error. We need to give this URL in the form of tuple. So let this get closed, and then I will write comma over here. Now I think it should be working. Let's see. Yes, perfectly. It is working right now. And if you go ahead and see your text documents, again, you will be able to get all the information from that particular web page in the form of URL, okay, or in the form of documents. So this is perfect. You are able to get every information over here. And with respect to this, you will be able to see that, yeah, you have all the information, and you can also see the page content, and everything looks fine. So these are some of the ways how you can specifically make sure that you probably get all the content from a page itself. One more thing, this is not underscore, this is dash. So now I think you'll be able to see more content. Okay, so let me just open this. So here you'll be able to see all the content itself. So this is one more way. One more way is directly to read from the PDF itself. So what I will do is that I will quickly create a PDF. Okay, so let me do one thing, and I will upload a PDF over here. Okay, so here I have created this attention.pdf. This is nothing but attention is all you need. Now using document loader, you can also directly read completely from the PDF itself. Okay, and how to do that? See, still we are in the data ingestion phase, and how do we do this? We'll also see that. So from the same library that we'll be using, again, we have to focus on document loader, and here I will copy and paste it. Okay, and this is basically my PDF reader. One more library dependency will be there. Okay, so we will try to install that also. So here I'm going to write py-pdf loader. Okay, and again I will be using loader is equal to py-pdf loader, and I have to give my PDF name, right? So PDF name over here specifically is nothing but attention.pdf. So it is in the same folder itself. So here I will write attention.pdf. Okay, now I think I should be getting an error. If I don't get an error, I will definitely install. Yeah, I'll install it now. See, pip install py-pdf. So here I will make sure that I will write requirement.txt and I will write py-pdf. Okay. So all these things you really need to take care of, because there will definitely be dependencies, because, and understand, RAG is one very important thing that really needs to get created in the form of application. So that is the reason I'm creating this completely from scratch. So pip install -r requirement.txt. So this is also done, I think, and py-pdf is also installed. Perfect. Then the next step, again, I will go ahead and execute this, and but here also the same step will be required, loader.load, and this will basically be my documents, and I will execute this. And once I probably execute this, this is my docs. Okay. Perfect. So here you'll be able to see my entire PDF has been read and it is in front of you. Now the next step. Now see, this load data source part is basically done. We know how to load it. Okay. Now we will move towards this transform. Okay. Then we will go ahead towards embed. Okay. So the first part of load I've actually done with respect to PDF, web-based, with respect to text file. If you go ahead and check out the Langchain documentation, there are still more amazing ways to do for Excel file, for README file, different directories, even for directories. Let's say that you have a lot of files in the directory itself, many files, and you can also load that. So we'll try to see in upcoming videos more about different examples. But here, just to give an idea about load data source, and load is actually done. Now let's go ahead and do this transform. Now transform is very much important. Now understand, guys, this is your entire PDF documents, right? Now you need to convert this PDF documents into chunks. Now how do you do that? And again, there are multiple ways, and this ways entirely falls inside the category of text splitter inside Langchain. So here we are going to write from Langchain dot text splitter import recursive character text splitter. We'll try to split it with the help of text itself. So here I'm going to create my text splitter is equal to recursive character text splitter, and here I'm going to specifically use my chunk underscore size is equal to 1000. I want this specific size to be the chunk, and let's say the overlap chunk overlap. Okay, chunk overlap. So here I will go ahead and write chunk underscore overlap is equal to 200. I'll keep this as 200. Okay. So once I do this, now this text splitter will be responsible. Text underscore splitter dot split documents will be responsible in splitting all the specific documents that I give over here. Okay. So this docs will be there, and this will be my documents, final documents that I will be able to see. Okay. Let's display this documents, the top 5 documents till here. Okay. And let's see this. So here you'll be able to see provided proper attribution is Google by grant permission, best model, this, everything is there. Attention.pdf, right? So all the information is basically there. And with respect to this, if you really want to see the more things, more different all the documents in short. So you can also go ahead and see the entire documents over here. Okay, done. So these are all my documents over here, transformers, everything is available over here. Now see, this is my entire documents. It has been divided into proper smaller chunks. Now we can take these chunks and we can convert that into vectors. Okay. And that is what is given you an idea over here, right? Like how we have transformed. We have basically taken this entire PDF document and we have divided that into chunks. Now it's a time that we understand how to probably convert this into vectors, and for this we will also be using some different vector embedding techniques, right? One of the vector embedding techniques that I will be showing you is with respect to OpenAI. So here now we will go ahead and probably write about vector embeddings and vector store, right? Vector embeddings is a technique wherein we convert a text into vectors. Okay. So how do we do that? Again, with the help of OpenAI. So here I'm going to write from Langchain underscore community dot embeddings import OpenAI embeddings. You can also use Ollama embeddings. It is up to you, since if you don't have OpenAI API, you can use Ollama embeddings directly. But the performance of OpenAI embeddings is better, far more better than Ollama embeddings. Okay. So here, what I'm actually going to do next thing is that, first of all, we need to understand how to probably create vectors. Again, to create vectors, we can use OpenAI embeddings, but After creating the vectors, we also need to store in the vector store. That is what it is, right? This vector store is like kind of a database. Embeddings is a technique where you convert text into vectors, but later those text needs to be stored in some kind of vector store, right? So for this reason, we will be using something called as ChromaDB. So there are a couple of vector databases that has been provided by LangChain itself. One is Chroma, one is Fias. As we go ahead, how to create this kind of vector database in the cloud also, I will show it to you. So from LangChain_community, I will be using .vector stores. And here I'm going to import, one is nothing but Chroma. So with respect to this, we will go ahead and create my DB. And here I'm going to write Chroma.from_documents. Okay, from documents. And here I'm going to basically give my entire document. Okay, entire documents. And I'll not give the entire documents. Let's just give the first 20 documents itself, because it will take more time to create the embeddings, right? And here the embeddings that I'm going to specifically use is nothing but OpenAI embeddings. Once I execute this, I think I'm going to get an error saying that Chroma is not available. I don't know whether I've installed Chroma or not. So here you can see pip install ChromaDB. I really require ChromaDB. So again, I'll go back to my requirement.txt. The reason why I'm showing you all this completely from scratch, so that you, whatever error you face, you should be able to fix it up. Okay, so I'm going to delete this, and let's go ahead and write pip install. One more library that I will be using is nothing but Fias CPU. Okay, Fias CPU, because Fias is also one type of one type of vector database. Okay, so -r requirement.txt. So let's install both the specific libraries. It will take some amount of time. Again, it depends on your internet speed and how fast your system is. But yes, I think Fias CPU and ChromaDB is the kind of vector databases that we will be using. One assignment I'll give you, try to also use LANS vector database. From again seeing the LangChain documentation, you can actually do it. Okay. Now this is done. Once this will probably be done, then we can go ahead and check by executing it whether it is working now or not. But at the end of the day, here what we are actually doing, we have imported OpenAI embeddings. The vector database that we are going to use is Chroma. Then Chroma.from document, I'm giving the entire document, and using this embeddings, it will be storing inside this particular vector store. Now this DB, we can store it in our local, we can store it in the cloud, wherever you specifically want. Okay. So guys, the installation has been completed. Now let's go ahead and execute this Chroma part. Now here you'll be able to see that entire embedding will basically happen. And again, we are going to use the OpenAI embedding for this. And now this DB is nothing but our vector database. Okay, so if I probably consider vector database, and now all I have to do is that I can query anything with respect to this particular vector database to retrieve any kind of result that I really want. So I will create a query first of all. So here, let me go ahead and write my query. So query is like, I will go ahead and write, who are the authors of attention is all you need research paper. Okay, so this is my query that I'm going to specifically ask. Let's see whether it will be able to understand this or and it will be able to give us the result. So here I will go ahead and write db.similarity search. Now there are multiple options. Similarity search by vector. If you want, you can also convert your data into vectors by using again the OpenAI embeddings, and you can query it from here. But we are just going to use the similarity search since we are just going to use the query over here, right? So if I write db.similarity search of query, so this will basically be my result. Okay, now let's go ahead and see my result. Okay, and let's execute this. So here you'll be able to see that I'm able to see multiple information, like 4 documents has been over here. So let's take the first document and let's see how the result is. So here I'm going to basically take 0, and inside that the field name is nothing but page content. So I'm going to basically write my page content. Now here you'll be able to see provided proper attribution is provided, Google hereby grant permission. And here you'll be able to see Google Brain, all the email IDs, all the researchers names are actually available. So that basically means it is able to retrieve the results of all the scientists who are involved, all the researchers who are involved in creating this particular paper. I can also do one more thing. I can go ahead and write what is attention is all you need. Okay, attention is all you need. Okay, So let's see what kind of results I will be able to get. And understand, this is entirely a RAG pipeline which is being able to come from the entire documentation. And here you'll be able to see that result is also coming up. Let me write something which is available in the research paper. So let me open my research paper over here and let me ask some question directly. Okay, from here you will be able to see when I'm searching attention is all you need, it is coming from here itself, right? So let me use something over here. Let me just write over here. Encoder is what is an attention function? Let me just go and search this. Okay, let's see. Attention is something, some text is there over here. So if I go ahead and execute it, and here you'll be, instead of performing a single attention function with the model dimension, values, keys, and all the information is basically coming up, right? And here is a very good result. And this is directly coming from the vector database. That is the most amazing thing over here, right? Now you may be also thinking, Krish, can we also use the FIRE database, FIRE vector database that we have used, right? So let me just show you with respect to that also, FIREs. And here I'm going to use the FIRE vector database. And this will also give you an idea how you can actually store that embeddings into FIREs database itself. And we'll also do that. So here I'm going to write from Langchain underscore community dot vector stores. I'm going to import my FIREs, and then I'm going to also use tb is equal to FIREs dot from documents, the same thing, right? So from underscore documents, and here I'm going to use my documents. Okay, and let's say I go ahead and do the embedding for the first 20 documents, and then here also I'm going to use my OpenAI embeddings. And I think this is also my another DB, so I will write it at DB1, which is my FIREs database. Okay, from documents. Okay, no worries. So here the spelling mistake was there. And I think this will also work. Now DB1 is also ready, and what I can do, I can use the same thing and paste it over here. Okay, and just write DB1 dot similarity search, and here you can see, instead of performing a single attention, everything is probably coming up. So I've just shown you the example of both FIREs and Chroma database, Chroma vector database. As I said, one assignment will be given to you as regarding LANS vector database. You can go and search it for that in the Langchain documentation. We are going to continue the Langchain series, and now we will be developing advanced RAG pipeline using retriever and chain concepts that are available in Langchain. Now, before I go ahead, I really want to talk about a funny incident that really happened recently, just today itself. So what I do is that every day morning, I usually go and play some badminton. I play for 1 hour, 1.5 hours, and usually a lot of my friends and neighbors usually come and play. So today what happened after playing, I went today in this look. Okay, I played around 3 to 4 games, and then one of my neighbors said, "Hey Krish, you're Krish, right? You just got identified right now. Just by seeing your shoes, I identified you, but your look has completely changed." So let me know if this is true in the comment section of this particular video. But I am liking this look. It's like so much of less maintenance. You don't have to maintain your beard, your mustache, or your hair also, right? It looks super cool. Now let's go ahead and work towards this specific project. In our previous tutorial, what we had actually done is that we had created this simple RAG pipeline. Okay, we had a data source, like we took PDF, we took website, then we load that particular data set using different data ingestion techniques that were available in Langchain. Then we did transformation, wherein we broke down our bigger PDFs into chunks, and then we converted all these particular chunks into vectors and stored it in a vector store. And then with the help of query, we are able to probably retrieve some of the data that is available in the vector store. Now this is one step. Now the further step after this particular query vector. Now understand, query vector are not that efficient, when in terms of retrieving the entire results. Here we will also specifically use LLM models. Okay, so now what we will try to do is that using some prompts, okay, and we will take this specific prompts, we will take this particular data using the concept of chain and retriever. Okay, and understand this topic is very important because this is where your advanced RAG pipeline implementation will start. Using chain and retriever, we will also use, and in this chain and retriever, what we do is that we specifically use LLM models. It can be open source, it can be paid, whatever model you want. So we will specifically use this LLM model, and based on this prompt, we will try to get the response on what we are specifically looking, right? So there will be a lot of customization that will be added once we implement this specific part. In the first part, we discussed about this, and this is the second part that we are going to discuss. Okay, how we can use chain, how we can use a retriever, what exactly is chain, how you can integrate in this particular LLM model. There is a concept of something called a stuff document chain, what exactly it is. So we will discuss everything all about it, and here we are also going to do a practical implementation. So please make sure that you watch this video till the end, and we are going to learn a lot of things. Okay, so here the first step, what we had done on already, we have implemented this in our previous tutorial also. So here you'll be able to see that I am trying to read attention.pdf, which is present in a folder, and then we just write loader.load and we get the documents. Okay, so these are all the documents that will be available in this specific PDF. Okay, then what we are specifically doing next step is that from langchain.textplater, we will be using recursive character textplater, wherein we convert the entire document into chunks, right? And then we are probably using this textplater, and we are using a chunk size of 1000, overlap of 20. So this everything is implemented in my previous videos, right? So we are going to split this entire document and save it in this particular document. In the previous tutorial, we have implemented all these things. Now, here, what we are going to now, we'll take all these documents and then we will convert it into a vector store, right? So vector store, for that we are using this files. Okay, so here we can use Ollama embedding or OpenAI embedding, right? As I said you, OpenAI embedding is very much advanced and it will perform better than Ollama embedding. If you don't have OpenAI API key, use Ollama embedding. Instead of OpenAI embedding over here, you can just write Ollama embedding, right? So from here, I will be using Fias, which is again a kind of vector store, and it has been developed by Meta. So Fias.from documents, document of 20. So I'm just taking the first 20 documents and I'm just writing OpenAI embeddings. Let's make it to 30 so that it will have some amount of data. Right now we are specifically using OpenAI embedding, and this DB that you specifically see is my vector store. Okay, so here you can see vector store Fias of type. Okay, perfect. Now, any question that I ask, attention function can be described as a mapping query, and then we can take this vector store and just write dot similarity search on this query, and we will get the result over here. Okay, so this all things we have actually done in our previous video. Now is the most important thing, how I can combine prompt along with chains and retriever, and then probably get a response based on the prompt. Okay, so since many people have the use of only open source, they have the access of open source model, LLM model. So I'm going to use Ollama from langchain.community.llms, import Ollama. Then I'm going to use Ollama over here. Model will be Llama 2. If you don't have Llama 2, just to go to command prompt after downloading Ollama. I hope everybody knows how to download it if you're seeing my series of videos. Here you can just write Ollama run Llama 2, right? So once you write like this, then the model will get downloaded. Right? If it is already downloaded, it will be coming something like this. Okay. So this is the first step that you really need to do. Then I have written from langchain.community.llms Ollama, load Ollama. So whatever Ollama model we are specifically using, that is Llama 2. So this is my open source model. So if you see Llama LLM, it is nothing but Ollama. Now is the time we will start designing our prompt template. Now, in order to design the chat prompt template, I will be using langchain_core.prompts import chat prompt template. Okay. And then from chat prompt template, I'm just writing like this. So I'm saying answer the following question based only on the provided context. Now see, we are trying to develop a Q&A chatbot. Based on the context, it should provide me the response. Previously, what we are doing using vector store, we used to, if you see the code over here, we used to query the vector store, right? Vector store by using similarity search algorithm. But here what we are doing? Here we are defining our own prompt and we are saying, hey, answer the following question based on the provided context, right? I will, and simply I'm writing away, I'll tip you $1,000 if you find the answer helpful. Okay, if the user find the answer helpful. Okay, just at least by seeing money, the AI may perform well. And then we are giving our context, and then question will be input. Okay, why I'm writing in this specific way? Because this chain and retriever, right? you'll be understanding this context will be auto-filled and this input will also get auto-filled. Okay, how it will get auto-filled, I'll let you know. So now what I will do, I will execute this. Now I will go ahead and implement about chain. It is always a good idea, okay, to probably go to your browser and check about each and every topic that I'm explaining. So what does chain refer to? Chain referred to a sequence of calls, whether to an LLM or tool or data pre-processing step. The primary supported way to do this is LCL. Okay. Now, if you talk about chain, over here, there are multiple functions with respect to chain. One of the function that I'm going to use is create stuff document chain. Now, what this exactly does, this chain takes a list of documents and formats them into a prompt, then passes that prompt to an LLM. Okay? See this. This chains take a list of documents and formats them based on the prompt. Formats them into a prompt. Sorry, not based on the prompt, into the prompt. That basically means over here, if I go ahead and open my browser, here in the context, I definitely require my documents itself, right? Based on that context and based on this input, I will be able to give the answer, right? So based on this context and based on the input, right? Context basically means all the documents that are there available in the vector store, right? Inputs are what question I am asking, right? So with the help of this create stuff document chain, what is basically happening? This chain takes a list of documents and formats them all into a prompt, then passes that prompt to an LLM. It passes all the documents so that you should make sure that it fits within the context window the LLM you are using. So what it is exactly doing, it will take up all the documents from the vector store, it will put inside that particular prompt template, and then it will send to the LLM, and then we finally get the response. Okay, and that is what we will be using. Similarly, there are different things also over here, like create stuff document chain is there, create SQL query chain if you are working with respect to SQL database for natural language, and this is one of the very important project that I'll also do in the future. One or the other way, I'll try to use one or the other functionalities to just make you understand how we can use all these functionalities itself, right? But it is always good that we have a specific use case. Okay, now if I open this, okay, let's go ahead and create my chain. How do I create my chain over here? Again, it is very simple. So I will write from Langchain underscore community. So it is present inside community itself, or not community, sorry, chains. Langchain underscore chains dot combine documents import create stuff document chain. Now, how do I know this? Okay, I did not create this. I have already seen the documentation. Okay, that is the reason I'm writing. Then I will go ahead and create my document chain. Now, inside this document chain, as I said, I will be using create stuff document chain. Okay, that we have already seen. Now, inside this chain, two things are basically required. One is the LLM model, and the second one is the prompt that I have created. Because inside this prompt itself, the list of documents will be added. Right, whatever documents is basically coming from here, right, from my vector store, that will be added over here. Okay, so once I create this, so this basically becomes my document chain. Okay, very much simple. Now after this, we also have to learn about one very important thing, which is called as retrievers. Okay, so I will go ahead and write something called as retriever Langchain. Okay, now what exactly retriever Langchain is? It is an interface that returns document given an unstructured query. It is more general than a vector store, right? A retriever does not need to be able to store the documents, only to return or retrieve them. Vector store can be based as the backbone of the retriever. Now see, there is a vector store which is having some information, some vector stored in it, right? If I want to take out any data from there, right, I can actually do a similarity search, which we have already seen. Okay. But Langchain, what it did is that since we usually do a lot of programming in a way, right, wherein classes are used, interfaces are used. So it created a separate interface, which is called as retriever. And that interface has a backend source to that particular vector store to retrieve any information, right? Whenever a query is given, right, that entire vector store will be passing the information through this retriever. Okay. So what we will do is that here I will quickly open this. I have also written some amount of description so that it will be helpful for you whenever you probably go ahead and check this entire materials. Okay. So now what I will do, I will just go ahead and write db dot as retriever. Now once I do like this, db dot as retriever, this basically has become my retriever, right? So what we have done, db is our vector store. Already it is there. We have connected to an interface, which is basically this particular variable now. Okay. So if you go ahead and probably display this, what is retriever? It is nothing but it is a vector store retriever. Internally, you'll be also able to see that what all it is implemented, files and OpenAI embeddings and all the information are there. Now retriever is done. Chain is also done. Okay. Now it's the time that what I will do, I will try to use this retriever and document chain both together to probably see when we combine both of them, then only we'll be able to get the response, right? So with respect to this, now let's go ahead and create my retriever chain. Okay. So the next step is what? Since I need to combine both of them, one is retriever and one is the document chain, right? This document chain is responsible for putting the information in the context. When we combine both of them, then it becomes a retriever chain. Now, what is the definition? This chain takes an input as a user inquiry, which is then passed to the retriever to fetch the relevant documents. So it passes through the retriever, it is connected to the vector store. Then those documents are then passed to an LLM to generate the response. And this LLM that we are basically getting, it is basically coming from what? This document chain. Understand the flow. Okay, so let me just go ahead and mention this flow again so that it becomes very much easy for you. So whenever the users, this is my user, okay, whenever the user asks for any inquiry, okay, any inquiry. So first what it is going to this retriever. Okay, very much important. Okay, so this is my retriever. This retriever is an interface to what? Vector store, which has all the information, right? So once we basically get the retriever, then the next step, what it happens? It goes to what? It goes to my LLM model with some prompt, right? There will be some prompt involved to this. And how this is basically happening? With the help of stuffed document chain. So this stuffed document chain has already both these things combined, LLM and prompt, right? And then finally we get our response. I hope you are able to understand this, right? And this is what we have basically implemented over here. Now, how to basically create a retriever chain? So first, for all of this, again, I will be using a library with respect to chains. Okay, so from Langchain dot chains import create retrieval chain, right? And there are a lot of things, create QA with source chain, retrieval chain, this chain, that chain. I will try to explain you all of this. Don't worry. Okay. I will catch the right kind of use case and I will be showcasing you all these things. Don't worry about that. Okay. Then what I will do, I will take this entire create retrieval chain and then I will create my retrieval chain. So here I will write retrieval chain is equal to create retrieval chain, and here I'm going to use first parameter that I'm going to use is retriever, then the second parameter is nothing but document chain. So once I have this chain, right, now I will be able to invoke any queries. So I will go ahead and write retrieval chain dot invoke. Okay, and now what are the parameters that I have to give? Nothing. I have to give my input. So the input will be given over here, colon, and whatever input that I can give, let's say from the PDF, I have put some input over here. Let me just copy and paste it. Okay. So this is one of the text that is available in the PDF, that is attention.pdf. And now if I invoke this, you'll be able to see that I will be able to get the entire response. Okay. So retrieval.chain.invoke. And again, we are using open source LLM model, that is Llama 2. Okay. Yeah, I've used OpenAI embedding. So here you can see this is my input. This was the context, right? All the context information is there. And finally, I get the answer. And this answer, I will just try to save it over here. Something like response. response. Okay. And then I will execute response of answer. So this finally becomes my output that is probably coming over here. Okay. So this, if I execute it, the answer to the question is, right? And all the information you can see. The answer to the question, and it is retrieving all the details, right? So here you'll be able to see that how beautifully with the help of LLM, we have constructed this entire thing, and we have used this chains, retriever, and this is the first step towards developing your advanced RAG pipeline, right? So whatever question you ask, let me just open this and probably show you some more examples. Okay. So what I will do, I will just open my download page. Let's see my download page. I'll ask for any statement. Okay, just a second. Attention. Okay, so this is my thing. Let me just go ahead and search for anything. The decoder is the this and this. Okay, so I'll be searching from here to here. Okay, now let me go ahead and change my input and search for it. So chain.invoke I've done, and here I've got the response. Now let me just go and I think the answer to this question is 6. The decoder is also composed of stack of n6. Oh, it has basically taken this. No worries. Okay, let's take some more thing. I'll write scaled dot product attention. Some more examples. Oops. Error. Okay, just a second. Now I think it should not be. Okay, it is taking that question and it is trying to form some answers out of it. Okay, got it. It is not a mistake. I thought it was a mistake out there. Scale dot product is a type of this. See, I'm getting all the answers over here. We are going to continue the Langchain series, and in this video we are going to probably develop an amazing multi-search agent RAG application. What exactly is the project all about, what all new things we are going to specifically learn, and probably I think this is the most amazing thing that has been inserted in the Langchain library itself. Some of the amazing modules that are there which will actually help you to make your entire conversational chatbot quite amazing itself, right? So let me go ahead and discuss about this, what exactly we are going to do, what kind of projects we are going to implement here. So let's consider that I want to generate a Gen AI powered LLM application. So this is my LLM application that I really want to generate. And this, let's consider that it has dependencies on some of the other open source platforms or other websites or other data sources itself, right? Like RSIV. RSIV, if you don't know, like all of the research papers that are available will be available over here. If I probably consider with respect to Wikipedia, right? Wikipedia also has a huge amount of content. Similarly, I may also have, let's say, my own company's PDF, from where I also need to probably develop a Q&A applications, right? So all these things we will probably try to implement it. Now, the main thing is that here you have multiple data sources and you really want to integrate all them as a wrapper so that you will be able to implement this entire Q&A solution, right, over here. So here you're also going to learn about some new terms, and right now it is becoming very popular, like tools, right? Tools, what are tools in Langchain? What are agents in Langchain? What are toolkits? We'll also be learning about toolkits, right? And how do you probably create a wrapper on top of this particular toolkits. But if I just want to give a small brief introduction about tools, you can see that here I have dependency on this platform, I can probably use all these platforms as a separate tool so that I'll be able to ask any questions from this particular platform itself. Along with that, I may also have my own customized PDF, own custom data, which will also be in the form of vector embedding. So what I will do is that I will try to wrap this up in the form of toolkit, and then with the help of agents I will be able to execute any Q&A search that I really want to do it. Yes, I have probably told a lot of terms and topics over here, but let's go ahead and let's see how we can actually implement it. And all this implementation that you will probably be seeing will be quite amazing. A lot of learnings will be specifically there, and you will definitely be able to learn many things out of it. Okay, so let me quickly go ahead and open my
code file, and I will continue the same code file that I had actually implemented earlier itself, right? One more very important thing that I really want to talk about is that if you remember, I have uploaded 5 videos till now, and all those videos are with respect to some different applications, right? And that is how we should definitely learn all these topics so that we can actually get an efficient way of how things are basically getting used. Okay, so as usual, what I am actually going to do is that let me go ahead and search for Langchain tools. Okay, so here you'll feel, if you are able to see here, you have something called as Langchain tools. So tools are interfaces that an agent, chain, or LLM can interact with the world, right? So if I really want data from some other data sources, some other queries that I have, you can also include Google Search API over here. A lot of tools are specifically given by Langchain itself. You know, we have to really create a wrapper, and then we will be able to have a conversation with them. So some of the examples with respect to the tool, like what all tools are specifically provided, you'll be able to see in Langchain. These are all the built-in tools that you have: Alpha Vantage, FFI, RSIV, AWS Lambda, Bing Search, Brave Search, ChatGPT plugins, you know, DALI image generator. You can also be able to generate images. Then you have Eden AI, File System, Golden Query, Google Finance, Google Jobs, Google Lens, Google Places, Google Scholar, Google Search, Google Serpa. So you can probably use any of these particular tools to extract some of the data that you want. Let's say that I am planning to create a chatbot which will be research more oriented, and I will probably ask questions that will be related to different topics, research and all. Other than that, I will also try to create a wrapper on top of Wikipedia, and along with that, my other customized PDF files. Okay, so I will try to include all those things, and you can use any of this that you want based on your use cases, but I will try to show you an application how I will go ahead with. Okay, so let me quickly open a new folder over here. So I will go ahead and create a folder, and let me go ahead and write agents over here as my folder name, and I am going to create a file which is called as agents.ipynb file. Okay, now inside this particular file, I will go ahead and select my kernel. Step by step, I will try to show it to you how things will be working in this and how I'm going to build this entire thing. Okay, so the first thing, as usual, as I said, that I will be requiring RSIV, so you have to probably go ahead and install this. So I will go ahead and write pip install RSIV. So okay, SS, no worries. So I will go ahead and install it. It'll get installed in my VENV environment. Once this is basically getting installed, what I am going to do is that I'm going to use Wikipedia. I'm going to use RSIV also, and I'll create as a wrapper. Okay, so first of all, let's go ahead and create a wrapper on top of Wikipedia. So for that, what I will do, I will go ahead and write from Langchain, Langchain underscore community. So it will be present inside this community itself, all the tools that are available within the Langchain itself. Then I'm going to import Wikipedia query run. Okay, so I'm going to just write Wikipedia query run. I hope this works. Let's see whether this works or not. Okay, this is my Langchain underscore community, but I think it should be working now. From langchain.community.tools, import Wikipedia query run. Along with this, what I'm going to write from Langchain, I'm also going to use some wrapper class on top of it. Utilities import Wikipedia API wrapper. Okay, so I'm going to specifically use these two things over here. One is the Wikipedia query run and Wikipedia API wrapper. Okay, for Wikipedia, you don't require a separate API itself. Already Langchain is taking care of that. So if I go ahead and write and probably execute this Wikipedia API wrapper, I will say, hey, provide me the top K results, right? So how many results I want? Let's say I want 1. So I'll go ahead and write document content char max. Max to max, I will probably require 200 characters, okay, from whatever search I actually do from Wikipedia. You can increase it. So this will basically be my wrapper itself, API wrapper. Okay, so this in short is interacting with the Wikipedia to find out the so many number of results. So this is basically giving some configuration details over here. The next will be my tool. As I said, I will be using my Wikipedia query run tool. Okay, and then this will be initialized, and here I'm going to initialize my API wrapper with the API wrapper that I have defined over here. Okay, so this is what is my tool over here. So I'm getting some error, could not import Wikipedia Python package. Please install it with pip install Wikipedia. So I will go over here and requirement.txt, I will go ahead and write Wikipedia. Okay, I will be requiring this library. Along with this, as I said, I'm going to import also archive. Okay, so let me quickly go ahead and open my terminal, and I will start the installation over here. Okay, so let me go ahead and write pip install -r requirement.txt. So both these libraries will get installed that I specifically want. Initially, you actually require it. Whatever is there, these packages are available, and Langchain is just trying to integrate with that. And that is the most amazing thing over here. Okay, so now I don't think so we should be getting an error. So now it looks good. Now if you go ahead and write tools over here, or tool name over here, so here you can see Wikipedia query run. If I go ahead and write tool.name, you'll be able to see Wikipedia is my tool name. Okay, now this is one of the tool. Similarly, what I will probably do is that I will also take a website or a PDF, whatever it is, right? I will read all those kind of PDF. Okay, so that I will also consider that as a data source. So let me do one thing. I will probably create another tool over here. Okay, so let's see over here. I will go ahead and go to this website. Okay, so let me just see this website. I have just copied this. Okay, so this website. Okay, so this is the website that I will also be using, and I'll try to retrieve the content from here also. So in order to read this content from this particular website, I will be using web-based loader. As you all know, we have also discussed about that, because that is also one of the data ingestion thing, right? So I will write from Langchain _community dot document loaders, and here I'm going to specifically import web-based loader. Okay, along with this, as you all know, since I'm reading the content, I will be using files, I'll be using OpenAI embeddings and all. So let me copy it from here and let me paste it over here. Okay, so I'll be using files, I'll be using OpenAI embeddings, I'll be using recursive character text splitter, so that I'll be able to divide all those into chunks also. So everything will be used over here in this particular case. And one thing that you really need to understand why we are doing this, because this is my own custom data. Let's consider this as my own custom data. I need to probably convert this into a vectors. So here I will go ahead and load my loader, and here I will be using web-based loader, and I will give my URL, the URL that I had actually got from here. So this URL will be basically reading the entire page. Okay, once I probably get the loader.load, okay, loader.load, it will load the entire content from that particular website. So this will be my docs. Okay, after getting the docs, the next thing that I will do is my recursive character split. Okay, and here I am going to specifically use some chunk size. So this will basically be my chunk underscore size is equal to 1000. And then I will also be writing chunk underscore overlap, which will be nothing but 200. Okay, so this is some default configuration I have actually taken in this. And then I will also write dot split underscore documents. I will split all these documents that are available inside this docs. Okay, and I will finally get my documents itself. Okay, and this we have already done it many number of times, I think, in my previous tutorial also. Then I will go ahead and create my DB, my vector DB. So I will go ahead and write vector DB, and here I'm going to specifically write files dot from documents, and here I'm going to give my documents, comma, my OpenAI embeddings that I'm specifically going to use for this purpose, right? And later on, if I really want to convert this vector database into retriever, all I have to write is vector DB dot as retriever. If you don't know what is a retriever, it is an interface which will be able to retrieve the result from this particular vector database, right? So here will be my retriever, right? So this is my second important thing. So let me go ahead and write retriever. Okay, so I've created one tool, I've created one retriever. Tool is for Wikipedia, but still I have also installed archive, right? So I'm also going to use archive for the same purpose. First, let's all this particular thing happen. Now you have that vector, the vector store retriever completely over here. Okay, now the next thing that I am probably going to do over here is that I will take this retriever and use create retriever tool, so that I can actually make it as a in short, like if I really want to ask any question, I really need to make this retriever as a create retriever tool. Okay, so if you go ahead and search for LangChain, create retriever tool. Okay, so here you'll be able to see that this is what we are going to specifically use. And create retriever tool, you can see create a tool to do retrieval of all the documents. So we are going to specifically use this. Other than this, if you can definitely check out all the agents that are probably available over here for that purpose, right? And by that you will be able to implement things. So here what I'm going to do, I'm going to create my retriever tool itself. So I will write from LangChain dot tools dot retriever import create retriever tool. I will initialize this create retriever tool, and here I'm going to use retriever is equal to or whatever retriever name I have, and then this will basically be my LangSmith search, right? So because that is with respect to the LangSmith page. So, okay, LangSmiths underscore search, okay, so that it will be able to get identified, okay, like which tool I'm basically hitting or which tool I'm basically searching. Okay, and here I will give my third parameter and I will say, hey, search for information about LangSmith. I'll just copy and paste it. I've already done this in one of my projects. So here you can see the third parameter that I'm giving in the create retrieval tool is just like a prompt, like what I really want this tool to do. Search for information gain about LangSmith. For any question about LangSmith, you must use this tool. So in short, when I do this creator retrieval tool, right, it is basically creating a tool to do the search for that particular page, right? So here I'm going to write retrieval underscore tool, okay, and this will get initialized, right? So I have got one tool over here. One tool is Wikipedia, and the other tool, if you go and see this retriever underscore tool dot name, this is nothing but LangSmith search. Now the third retrieval tool that I'm actually going to create is specifically my own RCIF platform that I've actually developed. So for this also I will be having one wrapper and one query run. Okay, so this will basically be for my archive. Archive basically means the website where all the research papers have been uploaded. Okay, so let's create one more tool. So this is for this particular tool. Okay, and again the same thing that we will try to do is that we have to create a wrapper, API wrapper or archive wrapper, where again my document max search will be 200, and this will be basically for my query run. And here I'm actually going to get my archive.name, and here you will be able to see that this is my tool, right? So this is inbuilt tool that is also provided by LangChain. Wikipedia and Archive is provided by LangChain. If you really want to create your own custom tool, then you can also create like this, but like I have actually shown you, right? At the end of the day, you combine all these particular tools. So let me go ahead and combine it. So I will write tools is equal to, and let's go ahead and combine this. So the first tool that I have, I think it is name is tool only. Okay, so I have written tool. So let me go ahead and write wiki over here, wiki. Okay, wiki. Okay, so here I'm going to combine all these things. So first one is wiki, the second one is my archive, and the third one is my LangSmith. Okay, so LangSmith, this is nothing but it is a retrieval tool name, right? So I'm going to basically combine all these tools. So finally I got my entire tools over here. So this tools is nothing but it is a list of all the tools that you can see over here with respect to this. Now my next aim is basically to query from these specific tools, right? So for this I can do it in multiple ways, and that is where we will be specifically using agents. Okay, so let me just go ahead and tell you what is the main purpose of agents. Agents will be responsible in probably, see, if I go ahead and show you the documentation also, let me go ahead and show you the documentation. Agents, the core idea of the agent is to use a language model to choose a sequence of action to take. In Chain, the sequence of action is hard coded in code. In agent, a language model is used as a reasoning engineering to determine which actions should take place in which order. Right now, here you can see that I have given 1, 2, 3 tool in that specific order. So what my agent will basically do is that it will, whenever I perform any request, right? Whenever I give any input to my LLM model, it is first of all going to first search in wiki. If it is not able to get in from this particular tool, it is going to go to archive. Then it is going to go to retrieval tool, right? So from these three tools, it is going to get the query and it is going to provide you the response. Okay. So let me quickly go ahead and write from Langchain dot agents. I'm going to import create OpenAI tool agent, and here I'm going to define my agent name. And let me go ahead and write create OpenAI tools agent name. And here I'm going to give my LLM, my tools that I've actually created, and one will be my prompt. Okay. So the prompt and tool I have not yet defined. So what I will do here, I will show you an example like how you can probably call your prompts also, that is already available in Langchain Hub. But before that, let me go ahead and call my OpenAI API. So quickly, I will go ahead and call it. And then this is what I'm initializing my LLM models as. Okay. So I have actually created chat open API. So this is what I'm actually going to use. Okay. Now let me go. So this is my LLM model. The next thing is that how can I probably create a prompt? One way that I've already showed you of creating a prompt is just by using chat prompt template. But in Langchain, there is a module called as Hub. There people have already created, or Langchain has already created some amazing prompts, generic prompts, and they have uploaded over there. So in order to call from there, so I will write from Langchain, import Hub. Okay. And then we are going to give the prompt. We are going to get the prompt, and the prompt will be of this name. Okay. So we'll also see, get the prompt to use, and you can modify this. So there is something called as OpenAI function agents. And this is the username that is present in the Langchain Hub. If I go ahead and see what is the prompt over here. So I'm getting an error. Let's see. Please install Langchain Hub. Okay. So we also require Langchain Hub in order to use this. See, the reason why I'm showing you all these things is because so many different options are there. Langchain Hub. Okay. So let me quickly go ahead and run in the terminal, pip install requirement.txt. Okay. So this I will probably Langchain underscore hub. Let me see the error. What was the error over there? Okay. It should be something like this. Okay. So I will go ahead and write or see in the requirement.txt. The name is different. Now let me quickly go ahead and write it down over and install it. Right. So here you can probably see, yes, the installation is done. My agents is ready. Now let me go ahead and execute this. Now I think you should be able to see the messages. Okay. Now you will be able to see the messages over here. Now see, by default, whatever prompt is available in OpenAI function agents, you'll be able to see I have system message prompt template. There is prompt variable, the input variable is there. In template, you are a helpful assistant. So what we used to do manually, everything is available over here. The same thing, it will have one human message, one system message prompt template, one human message prompt template, right? Now you have the prompt, you have everything. Now we can go ahead and create my OpenAI tool agents. Once I probably create my OpenAI tool agents, now you can probably use this agent and execute to get any kind of response. Now, in order to use this particular agents, we have to use something called as agent executor. Okay. Agent executor. Please understand the flow. The flow is important, and that is how you will be able to understand this. So from Langchain dot agents, import agent executor. Okay. So agent executor is my next I'm going to specifically use, and I'll use this agent executor. Here I'm going to use my agent is equal to agent. Along with that, I will use my tools is equal to tools. Okay, whatever tools I've given, and then this verbose will be true, so that I'll be able to see all the details whenever I get any response. And this will basically be my agent executor. So this is basically responsible in executing anything, right? So now if I go and see my agent executor, so here you can see all the things, and it has also added runnable binding arguments over here, right? Now, in order to execute anything, see, if I write agent executor dot invoke. So once I write invoke and I give my input, and let me give the message, tell me about LangSmith. Now you should just think that from where should this input come. Already in our tools, we have RCIF platform, we have LangSmith search, right? And we have Wikipedia. So obviously this agent will execute and it will interact from the tool that is related to LangSmith. So once I execute this, here you'll be able to see what kind of response I usually get. Okay. So here you can see, tell me about LangSmith. LangSmith is a platform for building production grade application, LLM application, and this is probably coming from the tool itself, right? Now here, mostly the thing that you could not see, right? You could not see over here what exactly the thing was. The reason was very simple. I did not write the verbose parameter properly. Now you'll be able to see what details you'll be getting. See, once you write verbose is equal to true, you'll get all the details, what it has hit. Now see, invoking LangSmith search, right? It is basically searching the LangSmith search tool, right? Whatever tool was there, right? Let me go ahead and execute once again with respect to some different query, right? And here let me write, tell me about machine learning. Now I don't know from where it will go ahead and execute it, but let's see whether it will go with Wikipedia or RCIF, okay? So agent executor enters, invoking Wikipedia with machine learning. See, and automatically Wikimedia, it is probably giving you the entire result. Okay. Let me also try with something like RCIF platform. So I have one question with some research paper. Okay. Research paper name. So let me just go ahead and execute. What's the paper all about? The paper number is there, and in RCIF we'll be able to find out this. See, now it is invoking the RCIF with query, this particular tool, and here you'll be able to get the response. And that is the reason why I say this agent executor tools are probably the most important thing whenever you probably develop a RAG application.
Guys, we are going to continue the LangChain series. And in this video, we are going to create an amazing end-to-end RAG project with the help of open source LLM models and Groq inferencing engine. An amazing project altogether. Over here, I'm going to show you many more things. And the best part is that many of you were specifically requesting only for open source LLM models. So here I will try to show you from embedding to using all the open source LLM models. Along with that, what exactly is Groq inferencing engine? We'll also discuss about it. So here is the Groq inferencing engine. If you don't know about Groq, it is on a mission to set the standard for Gen AI inferencing speed, right? And it specifically uses something called as LPU, language processing unit. Okay, it is a new type of end-to-end processing unit system that provides the fastest inference for computationally intensive application with a sequential component to them. Why it is so much faster than GPU? Because it solves two LLM bottleneck. One is compute density and memory bandwidth. I've already created a detailed video before and spoken more about what exactly is LPU inferencing engine. But now it's time that we go ahead and implement some amazing solutions out here, right? So let me go ahead and let me implement this end-to-end project. And this project here, I'm going to probably use Streamlit over here so that you can actually see it in a form of web application. So first of all, as usual, what I will do is that I will go ahead and see in the requirement.txt here, you can see Groq is also available. And along with that, we'll also be using LangChain Groq. So both this is the most important part. Along with that, BS4, beautiful soup 4, so that we'll be also able to scrap from a website. So that is what I'm actually going to do in my project. So here you can see in Groq, I will create one folder that is called as, or one file that is called as app.py. Now quickly, let me go ahead and start the coding over here. First thing first, I will first of all go ahead and import all the important libraries, like import Streamlit as st. Along with that, along with Streamlit, I'm also going to go ahead and import OS. Okay. Now, the first thing that you actually require is the API access. So click on the API access of Groq and you will be able to access it completely for free. So once you go to this API access page, you'll be able to see that there is something called as self-serve through playground on Groq. So Groq Cloud also gives you a playground. Along with this, if you really want to use it for a commercial purpose, then you can see currently Llama 270B, that is 70 billion parameters, gives you 4096 context length. And the response that you will be probably getting is 300 tokens per second. This is quite fast when compared to OpenAI, ChatGPT specifically. And the price per 1 million token is somewhere around $1.70, similarly, Llama 27B, you can see 750 tokens per second. Then Mistral is there, 480 tokens per second. Gamma 7B, which is basically having 8K context length. And this is somewhere around 32K context length, right? 820 tokens per second. And the price is also very much minimal. So
As usual, you can see Groq has also demonstrated 15 times faster LLM inferencing performance on an artificial intelligence.ai leaderboard compared to the top cloud-based providers. So this is awesome, and you should definitely know this. So in order to create the API, I will go ahead and click on the playground on Groq. Once you go over here, you'll be able to see the button of APIs. So just go ahead and click on create API, give the API name, and just click on submit. Once you do that, you'll be getting an API name itself, right? And this API, this secret key only, I will be specifically using in my environment variable. So I'll show you step by step. Already I have created those kind of API keys. So please make sure that you also update your environment variable. I'll tell you with what name you really need to update, right? Now here we have done this. Now since we are going to use this Groq with chat Groq itself, and that is already present in Langchain, right? So here what I'm actually going to do, I'm going to write it from Langchain underscore Groq import chat Groq. Okay, chat Groq. So this is the chat. Oh, here I have made a spelling mistake. Langchain underscore Groq. Okay, import chat Groq. So chat Groq is like how we use chat open API. Similarly, chat Groq is also there for this purpose. As you all know that I'm going to probably take a website and read all my content from that specific website itself, right? So here what I'm going to do is then again from Langchain underscore community, I'm going to use web-based loader again from Langchain underscore community. Then I'm going to use document loaders. As you know, this is the first data ingestion technique that we can actually use. Import web-base document underscore loaders, web-based loader. Okay, so I will specifically use this particular Langchain underscore community document underscore loaders import web-based loader. Along with this, what I'm actually going to do, as I said, I'm going to only use open source models. So first of all, let's go ahead and do this, and I'm going to use Langchain. And one of the embedding technique that I'm specifically going to use is Ollama embedding, because it is completely for free. It is an open source itself. So Langchain underscore community dot embeddings import Ollama embedding. So here you don't even have to worry about anything about OpenAIs, right? So Ollama embeddings, I'm going to use it over here. Along with this, what we can do is that since we are going to read the entire document and convert that into smaller chunks, so for that I will be using recursive character splitter. So again from Langchain under dot Langchain dot, again I'm seeing the documentation, guys, so I need to know where this library is actually present, the recursive character text splitter. So from Langchain I will be using dot text splitters, and here I'm going to import recursive character text splitter. Okay, so this is another library that I'm going to specifically use for this purpose. And as you know that I've already shown you how to use create stuff document chain. So for that also I will be using from Langchain dot chains dot combine documents import create stuff document chain. Okay, so this is the another library that I'm actually going to use. Along with this, I'll create my own custom chat prompt template. So again from Langchain dot underscore core dot prompts, I'm going to import Langchain underscore core dot import a chat prompt template. Okay, so chat prompt template I'm going to use along with this. And as you know, after creating the document chain, I also have to create the retrieval chain. So from Langchain dot chains, come on yaar, from Langchain dot chains. Okay, sometimes all the time when I'm writing Langchain there is a spelling mistake, come on. Okay, import create retrieval underscore retrival underscore chain. Okay, so yes, one more libraries with respect to this. I'm going to use all the specific things for my purpose, and as you all know that I'm also going to use one more thing so that I'll be able to load all the environment variables. So from dot env import load underscore dot env, I'm also going to import os. I've imported os. So load underscore dot env, I'll just load this so that all my environment variables will loaded. And one of the environment variable that I'm going to specifically use is Groq API. Okay, so let me load the Groq API key. Okay, so that whatever I'm specifically running, I'll be able to use the open source LLM models from this specific inferencing engine. So here, let me go ahead and write Groq underscore API underscore key is equal to os dot environment. Okay, and here I'm going to use Groq underscore API underscore key. That basically means whatever Groq API key I've taken, I've written in my environment variable with this key is equal to whatever my API key I've got from that particular website. So, okay, so you also have to really do the same thing. Okay, so whatever key you actually get, you have to take this in the name and you have to probably go into your environment variable. So environment variable is somewhere here and just assign this with that whatever key name, because I have created a lot of key over there. And since we are continuing the Langchain series, I'm going to probably do in this specific project itself. Okay, so once this is done, here one more thing I'm going to specifically use in Streamlit. I'm going to use something called a session state. So all those things I'll also be doing with respect to this. Okay, and that will also help you to understand. So here I'm going to write if vector not in, okay, st.session underscore state. I'm going to create some session states so that you'll be able to understand. So first thing that I'll be creating with the session state is nothing but my Ollama embedding, and probably you'll also get an idea in this video about many things, session states and Streamlit and all. Okay, so first of all, I'm going to create my embeddings. This embeddings I'm going to assign to my Ollama embeddings. Okay, so this is the first parameter that I'll be using. Then I'll be using session loader. So session underscore state. Okay, and along with this dot loader, so I will load some information from my website. Now what website I'm actually going to consider, let's see. Initially I've used some kind of websites over here, at least somewhere I've used some websites. Let's pick up any of the website over there. Okay, I'll probably take previous examples. This is done. Agents is the agent. Let's see what example I've actually taken. Okay, let's pick up this website. Okay, so I'm going to use web-based loader along with this website. Okay, so here I'm going to write web-based loader, and here will be basically my website link. Okay, so I'm actually reading the content from this website. Okay, so let me quickly open it over here for you so that you will be also able to see it. Okay, so it's a docs.smith chain langchain, some information I want from here, so I will try to pick it up from here itself. Okay, so this becomes my loader. Now after getting the loader, what we really need to do is that we need to from this particular website we need to get the entire documents. So I will create another session states, session underscore state. Okay, dot docs, and I will say loader dot, oops, not loader, it should be this one, st dot session state dot loader dot load. Okay, so once I load it, again the same thing, whatever we have specifically done. Now after getting the docs, what we have to do is that we have to probably use this st dot session underscore state. Now you know what we specifically do after that. We get the final documents or chunk documents, right? So I'll write chunk documents, because I need to do over here as recursive character splitter, right? So here I'm going to use recursive character splitter, and here inside this recursive character splitter I have to probably consider this as my docs. Okay, sorry, over here I will probably be assigning my, or instead of writing this chunk underscore documents, I will write text splitter. So this will basically be my text splitter. Here I will be using chunk underscore size is equal to 10,000 or 1,000. I'll go and write chunk underscore overlap will be somewhere around 200, right? So this is done. Good. We have our text splitter. Again, that is also saved in the session itself. So now I'm going to basically go ahead and write st.session session underscore state, and here I'm going to create my final documents. Okay, and this final documents will be used along with this st.session state.text underscore splitter, and here we are going to basically use dot split underscore documents. Okay, and we are going to probably take the documents over here. Documents is nothing but all the documents that is available over here. Along with this, we are going to use the embedding, that is nothing but st.session underscore state dot embeddings, right? Embeddings, I think it should be coming up, right? I think it is the same thing, st.state.embeddings, right? So this basically becomes your final document. Okay, so final documents, and here you can probably see all the things are available, right, with respect to all the session states that are basically getting created. Now the next thing that I also need to do after probably getting the form, all the documents form, then I have to really convert that into vectors also and store it in a vector store. So from Langchain underscore community, inside this community I'm going to specifically use my vector stores. Okay, so lang all the time. C will be coming before G. So how many of you are also doing the same mistake like me? Okay, so from this one, I'm going to import fires. Okay, now this fires that I've actually initialized, again, I'm going to store it inside my session underscore state dot, I'll name it as vectors is equal to, I'll be using fires dot from documents, and inside this, as you know that since we are going to use this functionality of from documents, two important things I have to really give. One is all my documents, all my final documents. So here I will give my first parameter as final documents over here. Okay, and the second one that I'm specifically going to give is nothing but my embeddings, right? So this will specifically be my embeddings, right? Done. So this is perfect. Here you'll be able to see that I'm able to see all the documents, everything as such, and this is all in short my these vectors will get created. Now I can probably ask any questions from this particular vectors. Okay, but since I really need to create this as an end-to-end project, so I'm going to use multiple things. One is st.title. Okay, and here I'm going to basically use chat Groq demo. Okay, chat Groq demo. Now let me go ahead and create my LLM. My LLM is nothing but chat Groq, and inside this I'm going to specifically take my Groq underscore API key, which will be initialized to my Groq underscore API key, right? So whatever Groq underscore API key, I'm actually getting it. Okay, along with this, the model that I'm going to specifically use, there are multiple models as already said over here. So let me check out what all models are there. So you have this Gamma 7B IT, right? Or you have this Mistral 87B 32768. So I will use Gamma 7B IT. So let me quickly go ahead and over here, and let me write in my name. Model underscore name is equal to, so Gamma, I think it is capital letter, Gamma 7B. So this will be Gamma 7B IT. I think spelling is right? It's capital IT. Is it capital IT or 1T? Okay, if it does not work, I'll change the model name. No worries. I have three other options. Capital IT. Okay, I think it should be capital IT. Okay, so once this is done, my Groq, my model name, everything is basically created. Then this is my LLM models. Now what I will do is that I will also go ahead and create my prompts. So let me go ahead and write prompt chat prompt template dot from template. So there are also some templates that is defined. You can also create chat prompt template from scratch. Okay, so I will say answer the question, or so here I'm going to basically use some context also. Answer the questions based on the provided context only. Okay, so here I'll write please provide the most accurate response based on the context. Okay, so this will basically be my thing. And one very important thing is that I can also specify based on the question. Okay, now let me go ahead and define my context. So here I will basically define my context, and this will be ending over here. So let me go ahead and write it. So this will basically be my context, and here I can give my context like this. Now the next thing that I usually give is nothing but my question, which will be my input parameter over here, right? So this will basically be my input. Okay, so this becomes my chat prompt template. This is very good. Now, as you know, what are the next steps? We have to probably use document chain. So I will go ahead and use document chain over here. Then I will specifically use all the vectors in the form of as retrieval, right? So that this is just like an interface to probably read all the data context that I specifically get from this particular vectors. Now, since we are using all these things, right? Like we are using this chat prompt template, we are using some context based information, then document chain, retriever, and create retrieval chain will also come into existence. Now, create retrieval chain, already I have explained in my previous video. Here I am going to combine my document chain and the retriever. So both of them will be specifically combined. And now I will go ahead and probably write my prompt. Prompt will be st.text underscore input. And here I'm going to define my input your prompt here. So guys, now next step, what I can actually do is that LLM is ready, my prompt is ready, my retrieval chain is ready, everything is ready. Now, all I have to do is that I will write if prompt, okay. If the prompt is there, I will go ahead and write my response, okay. And with respect to response, I will be using this retrieval chain. So let me go ahead and write retrieval chain dot invoke, okay. And whatever input I'm specifically giving, right, with respect to this particular input, and that should be in the form of dictionaries, okay. And here I'm going to write input colon prompt, right. So done. So this is also done. Perfect. I'll be able to get the response over here. Now it's always a best way that if I really want to get the response, right, I go ahead and probably use some timer out there, right, so that you'll be able to see it, like how much time it is probably taking. So import time, I have to imported time over here. Now as soon as probably I go ahead and hit the prompt itself, right, as soon as I press enter, you know, the timer should probably start over here. So I'll write starter time dot process time, okay. So this will basically be my process time over here, and then I will go ahead and write print, okay. Or I don't have to print also over here, nothing, okay. What time it will start and all, we can probably do it, but again I can go ahead and write print response time colon, okay. And whatever is the response time, I can specifically do the subtraction over here itself, right. And here I can just write something like this, the current time, that is time dot process time, okay, process time minus start, or whatever is the start time, right. So I can specifically get this, and I'll be getting the response itself. And once I get the response, I will go ahead and write st.write, and this will basically be my response of answer, okay, whatever answer I'm specifically getting, okay. So yes, almost done each and everything over here, and I think we'll be able to get all the things with respect to this. But again, it is a good idea that you know, you also try to create an expander where you probably get all the context also, what it is basically getting retrieved. So a small 4 to 5 lines of code that I will be adding it over here, right, with a stringmate expander. You can see I'm taking up all the context. From that context, I'm taking the page content and displaying it over here, right. Now let's go ahead and run this. I think it should be working absolutely fine. Amazing end-to-end project where we definitely learn a lot of things. And here finally you'll be able to see Streamlit run agents, app.py, right. But I think it should be running, and we'll see the speed, because the speed will be the most important thing. So let me go ahead and cd Groq, and now same thing I will go ahead and write. Now I feel now the most excited thing that I will probably be excited about this application is how quickly I'm able to get it. So textsplitter.split documents take 2, position number 3 were given. Let's see. This kind of errors usually comes, but it's okay. Recursive text splitter, is it regarding recursive text splitter? Splitter documents, okay. Where did I give 3? Splitter documents, let me see in the documentation. But again, this kind of errors will definitely be coming up. Okay, here I don't require embeddings. Okay, so one is only required. I just saw the document, so that's it. Okay, sometime it happens, but it's okay. Now probably whatever question I asked from here, okay, let's see. I will go ahead and ask this. Now I think it should be running. Let's see. It's stopping. It's a second. But there are a lot of content from here, so that is the reason I think it is taking so much of time. I think for the first time, for the indexing purpose, it is probably taking a lot of time. Let me delete this once again. Terminal, let me do one thing. Okay, let me to just improve the performance, right? I will just not take all the documents over here. I will just take some documents. Okay, let's probably take the initial 50 documents. That is how I'm going to probably do it. Okay, initial 50 documents. If we are able to do that much, I think it'll work out. I don't want the maximum number of files that will probably create me a problem over here. Okay, command prompt, let's see, open cd Groq. Okay, Streamlit. I think it will take some time because I'm saying that as soon as the page is getting loaded, this needs to be embedded or indexed. Okay, so Streamlit run app.py. Let's see if this works faster. I will not show you the other one then. Probably it will take some time, because the entire website is basically getting indexed. And let's see how much time that vectors will probably get created. That is how things are basically happening over here. Because we are taking the first 50 documents, but I hardly see that 100 to 200 documents because it's a big website, this document.smith.langchain, right? So you can see this is a big page. And there are so many things that is already available over here. Okay, let's see how things goes ahead. And okay, st.session has no attribute vector. Did you forget to initialize it? Okay, one more error. Okay, let me see. Store vectors. Okay, vectors is used over here. Let me see. Okay, vectors. I understood the error. It's okay. We can understand the error. Okay, now I've again reloaded it. It is going to take some time, hardly 10 to 15 seconds, because it is going to index this entire page. And for the first time indexing, it is going to take that much time. So guys, whenever I'm probably searching things, right, and it is giving me some of the document similarity search, but with respect to the summarization from the LangChain, it is not coming up. I find out that one of the reason is that Gamma 7b model, it has a very less context length, So if I probably consider over here and probably seen the API access, right? There are multiple models that we have specifically used, right? One is Mistral 8 into 7b, Gamma 7b, only 8K context length, 32K context length. Let's do one thing. Let's try some other model over here, okay? The Mistral model, and see whether it will be improving the performance or not, or whether it will be improving the accuracy or not. So you should be knowing all these things. I'm not going to edit any part of the video over here, so that you get an idea like how things works. And here now let me go ahead and run this and reload it completely, and now we will try to see it, okay, how the accuracy is. But again, we are going to focus over here and see that how things are with respect to this, right? But at the end of the day, it is being able to provide this context, whenever I ask any specific question based on that context. So I can just ask how to install a LangSmith, how to create an API key, how to set up an environment, something like that. Okay, so here, how to set up an environment. So let's go ahead and work it out. I think it should be there. Okay, it should be able to probably give me some kind of response at least now. And again, let's see this part also. Okay, it's working, but I think the document similarity search and everything we will be able to see it. Okay, and along with that, you'll also be seeing many more things, right? So many things that you can probably search out of it. So let's see. I think for the indexing purpose only, it is probably taking time. So the response time is less. See, to set up an environment, this, all the information are specifically over here. So this looks absolutely amazing, absolutely good, and that is how you can actually do it. And just you can imagine like what happens if you probably take an open source LLM models with a higher context length, right? So definitely try it out from your end. Again, you can ask any questions as such. Let's ask one more question over here. How to create an API key? Okay, how to create an API key? Create an API key, and if I execute it, So here you can actually see the response is there, and to create an API in LangSmith, you can follow the following steps. All the content that is present in the website is shown. Here you can probably see the entire document similarity search. So guys, I hope you are loving the entire Langchain series. We have almost completed almost each and every module specifically to Langchain that is actually required to create end-to-end projects. And we have also developed multiple projects over here. We have used both paid and open source LLM models. Now, one of the most requested video was that, Krish, how can we work considering Langchain along with Hugging Face libraries and making sure that you use only open source LLM models and try to create some amazing end-to-end projects. So in this video, I'm going to use Langchain, Hugging Face, and open source LLM models like Mistral that is specifically hosted in Hugging Face. And then we'll try to develop a Q&A RAG, complete RAG app. And I hope you will be liking this particular video. Please make sure that you watch this video till the end, because there will be a lot of learnings that you will be able to find from this particular video too. So let me quickly go ahead and share my screen. So here you can actually see I've created a folder called as Hugging Face, and there's some US census data which I probably downloaded from the internet in the form of PDF, and I have uploaded in this specific folder, right? So we will go ahead and probably read this. Again, we are going to use completely open source LLM models like Mistral using Hugging Face itself, and then we are going to create the entire Q&A application. So let's quickly go ahead and do this. And initially, as you know that initially we need to load all the data ingestion step, that is loading all the libraries, all the PDFs itself. So for that, I will be importing from Langchain _community, okay, .document loaders, import PyPDF loader. Okay, so this is one of the things that I'll be requiring. Then from Langchain _community .document loaders, I'm also going to make sure that I use a PDF directory also for that. So here I'm going to import PyPDF directory loader. Okay, and then from, since I, after reading it, I need to do the character splittings, divide that documents into chunks. So for that, I'm going to use recursive character splitter. Along with this, again, as we know that we'll also use some kind of vector store over here. So I'm going to use the vector store called as files. And as you all know, we are also going to use Hugging Face. So for Hugging Face, as I said, all the embedding techniques also I'm going to use from Hugging Face itself. So for that, in Langchain also you have this embedding techniques where you have Hugging Face BGE embedding, which is completely an open source and which is good enough, right? So we are also going to use it. Along with this, I'm also going to import NumPy as an NP. If I specifically require NumPy, I don't think so I will be requiring, but I'm going to just use this. Okay. Two more amazing libraries that I'm going to use from Langchain, since I also have to make sure that I create a template. So from Langchain.prompts, I'm going to import prompt template. Okay, so this is also what is specifically required. And one more, right? One more chains I will specifically require again from Langchain.chains, import retrieval QA, right? So retrieval QA chain we will specifically be requiring. So all these libraries we are basically imported and we are going to use this for this particular purpose. Now let's go read the PDFs from the folder. Okay, now here you have loader is equal to PyPDF directory loader, and here I'm going to give my census folder, right? So here I will go ahead and write .start US_census. Okay, so this census folder I'm going to specifically read, and then I'm going to use this loader .load, and I'm going to basically get my documents. Okay, so once I probably get the documents, then what I will do, I will create my text splitter, and for this I'm going to use my recursive character text splitter. And for this, the chunk size, chunk_size, I will be taking 1000. Okay, and chunk_overlap will be somewhere around 200. Okay, so all these things, as you all know, I've written this kind of code a lot. And then finally, my final documents, okay, will be nothing but I will be using this text splitter, and then I will split all the documents. So I will write split all the documents with considering all my documents over here. And let's go ahead and see my final documents. First final document, I'll just try to see. I don't have to display the entire thing. So this will probably read all the PDF file inside that particular US Census folder, which is present over here, all the 4 PDF files, and then it will probably give me a thing. So here you can see one error is there. So here, let me go ahead and write it chunk size. Now I think it should be working fine. And all the PDF, all the materials will be available in the description of this particular video, guys, for you, all of you, right? So here you can see, and the total number of length of final documents you can probably see is somewhere around 316. So here you can see page content, health insurance, cover status, everything is available over here. And this is the total number of documents that I'm actually able to get it, okay? Now, the next thing that I will be specifically requiring is the embedding technique. What embedding technique I'm going to use? As I said, I'll be creating Hugging, or let me just go ahead and write. See, you can use Ollama embedding, anything, but since I am planning to do it with embedding using Hugging Face, so I will be using all the Hugging Face components, and these all are also very good, completely open source and available for you from Hugging Face. So here I'm going to basically write Hugging Face embeddings. And the next thing that I will specifically require is my model underscore name. This is the first parameter that I will be giving. And that model number underscore name will be nothing but I have explored some of the model over here. That is this one, right? By this one is also there. Okay, so one embedding technique is this one. I can also use sentence transformers. Okay, so let me just show you. Instead of using this, I can also use this. So I'll write down a comment over here. Oops, just a second. I'll just write down the comment over here. Okay, so this also you can specifically use. Let's go ahead and use sentence transformers if you want. Okay, and if you don't want, you can also use this. No worries. It is up to you. Okay, both or any of them can be specifically used. It is up to you. Okay, and these are some of the free available embedding techniques that is basically available. Okay. So now I have actually created this. I will go ahead and write my next one. So before that, let me do one thing. Okay, and okay. So the model name is driven. Then I will be using model KWARGS, and I know I don't have to even use GPU, right? Because with the help of GPU, with the help of CPU, this is possible because I have very less documents. So I'll be using device colon CPU. Okay. So this will basically be my device with respect to this model arguments car. Okay. The next parameter that I'm going to specifically use encode underscore KWARGS, and encode underscore KWARGS will be here. I'm going to use a parameter which is called as normalize. So you may be thinking, Krish, from where are you probably considering this? I'm just checking the documentation from the Hugging Face itself, right? So if you go ahead and search for this, right, and you'll be also able to see some of the examples, right? So here you can see this. Okay, so here you just click on this, and here you will be able to get all the information. There will be some code files also which you'll be able to see. Sentence transformer is also there. See, everything is over here, right? All mini. This one only I told, right? So similarly, you can probably go and check for many of if you want. Okay. Now the next thing that you really need to do is that you have to set your access token of Hugging Face. Unless and until, in order to access all these models, Hugging Face token needs to be there. So I will go and click on settings in my Hugging Face account. There'll be something called an access token. Okay. And just make sure that you create this particular new token. So once you probably create it, you'll be able to see it. Okay. And then you can copy it and you can specifically use it. But anyhow, I will show you where we will be specifically using. Now, if I go ahead and execute it. So here, could not import sentence transformer pip, install sentence transformers. Okay. I need to install sentence transformers. So let me quickly go ahead and update my requirement.txt file. See, whenever error comes, some type of things is always going to happen, but it's okay. We should not be afraid of errors. You know, errors will probably help us to do anything that we want. Okay, pip install -r requirement.txt. So here you can see now the sentence transformers will also get installed, and finally you'll be able to see that okay, everything is getting installed itself. Okay. Perfect. Sentence transformers is coming over here, and now you'll be able to see that okay, once it is installed, then I think then you'll be able to execute this. Okay, so we'll wait till this installation basically happens. So if you have not subscribed, and please make sure that you write something in the comment section. How are all these videos for you all? Are you able to understand? I hope many people are able. See, whatever feedback that I'm getting from people with respect to the transition, I feel that yes, the videos are doing something in your life, at least some amazing things in your life, and I hope to do as long as I can. Okay, but again, my main aim is to teach you in such a ways that you learn things in a way that always it matters in your life, right? And that is what I'm actually looking at. Okay, so let's wait. Some amount of time usually takes for this particular installation, but I think once this installation takes place, we are good to go. Okay, and I'll also show you how you can actually set up the Hugging Face. You have actually created the Hugging Face tokens, right? But how to set it up as an environment variable? Still, it is saying that it is not installed. Yes, installation is taking some amount of time. So let me pause the video till then. I think it is going to take some time, and then we will continue. So guys, the installation is taken place. Now you can go ahead and execute it, and I think it should not give me an error now, and your embedding Hugging Face should be imported over here. Okay, so perfect. Let's see. It is going to take some amount of time again. It is going to take somewhere around at least 1 minute because this particular embedding is quite big. Oh, 13.1 seconds. This is absolutely amazing, and this is really good. Now, after you have this Hugging Face embeddings, we will try to use this Hugging Face embeddings and try to just check on one of the file. Okay, so I'll just go ahead and write embed underscore just to check whether it is working fine or not. Embed query. And here I'm going to basically take my final underscore documents of 0. Okay, so I'll just take the first one. Okay, first one, and probably I will just go ahead and use the page underscore content because it will be available over here. Now what I'm actually going to do, if I'm specifically using this Hugging Face embeddings, okay, I will also go ahead and import numpy. Let's see, import numpy as np. And let me convert this into an array, np.array. Okay, I think so. It should not be giving me an error. So we are just trying to see. Okay, perfect. So whatever was available in the first document of page content, this is how the embedding is basically shown for the entire words. Okay, whatever the words are specifically present in that particular embedding. And if you probably go ahead and see this, what is the shape of this particular array? Okay, I will also print that specific shape. Okay, let's go ahead and print this first. Print this first. Okay, and then we will print it. I will paste this dot shape. Okay, I think you will be able to see the shape 384. Okay, and it is also getting printed. So perfect. Now what we are going to do, if this embedding technique is working fine, then what we'll do, we'll convert for the words into vectors by using this embedding technique and store it in a vector store. So for that, I already have imported files. So I'm going to probably create my vector store, and I'm going to write my files dot, and then I'm going to say from documents. Did I import files? Yeah, it is imported from documents. And from the documents, what I'm actually going to do is that I'm going to give my final documents. Final documents till, let's say I give 120 records. Okay, there are somewhere on 310 records. I'm not putting all because it is going to take time. Okay, just to show it to you, but later on, once you have time, you can go ahead and increase this number. And here I'm going to basically use Hugging Face embeddings. Okay, so vector store will basically get created. So if I go ahead and execute this, again, it is going to take some amount of time, at least 30 to 40 seconds, because there are so many documents over here, and all this will be embedding, right? It will get embedded into words. And as you can understand, every document will be getting converted into 384 based on the chunks that we have specifically, 384 vectors. Okay, so this will basically be my vector store creation. Okay, and this is what is the step that we have specifically done in every step, right? Vector store creation. Perfect. So let's wait for some time, and I think it is 30 seconds. It has crossed since 120. Before, when I tried to do it, it took me around 30 seconds because there were only 100 documents. Okay, so 43.4 seconds. Perfect. Now we will try to use this vector store and perform query using similarity search. Okay, so similarity search will be basically done over here. Similarity search will be done. Okay, and once we specifically do the similarity search, we will be able to see, or we'll be able to get some kind of response over here. Okay, so how to do the similarity search? First of all, I will go ahead and write my query. With respect to the query, you'll be able to see I will just write a question. What is the health insurance? Okay. Now see, this question that you will be saying, I did not just write it by purposely or somewhere. Here, what I will be doing, wait, what is the health insurance? Insurance coverage. Okay. What I did is that I just went to this folder. Okay. And when I probably go ahead and see this folder, I will just open my first file. Okay. And this is where I saw this question. What is health insurance coverage? So I will take up this question itself. Okay. And I will paste it over here. Okay. Now, once I paste it, so this is the query that I'm actually searching. I will go ahead and write relevant underscore documents, since I need to probably retrieve that result that is present over there. So what I will do, I will use vector store dot similarity underscore search. Okay. And whatever query I have specifically written. Okay. Whatever query I have written. And let's go ahead and print all the relevant documents. Let's go ahead and print all the relevant documents. So once I print it, I think I should be able to. Oh, relevant. Is this not the same thing? Okay. So here you can see page 2, what is health insurance, and here you will be able to see the answer. This brief prevents stage level, everything. You are able to see this, right? Completely, right? And in order to get this, what I will do to exactly get the page content, so I will write underscore page content. So whatever question I'm specifically asking, you'll be able to see this is the brief present state level estimates of health insurance cover. Is it same or not? So this brief presents state level estimates of health insurance coverage using data from American Community Survey. American Community Survey. So here you can see the US census and all. Everything is working absolutely fine. Okay. Sometime you also may be requiring more results, right? More. Let's say right now I'm just getting one result. Let's say I want 2 to 3 results. Now 2 to 3 similar kind of results. Now what I can actually do is that according to that particular text or query that I've asked, the most relevant document I specifically want. So what I can do, I can basically write this vector store. Okay. Vector store. And I will specifically call as a retriever function. I hope everybody knows what is as a retriever, because we have discussed more different thing about it completely. As a retriever is just a kind of interface that gets connected to a vector store, so that you will be able to get more results, more amazing results based on the similarity search. And here I will say search type similarity, but my search underscore arguments, okay, will be nothing but my search underscore arguments will be nothing but k is equal to 3. K colon 3. Okay. So this is what I will be probably getting the vector store. Okay. And you can probably consider this as my retriever itself, right? So I will save this as retriever. Okay. And then let's print retriever. Okay. So here you can see Fies, Hugging Face embeddings, all the things, and the number of search arguments, like most relevant documents I require is 3. Okay. And now I can also use this particular retriever to invoke anything that I specifically want. But before I invoke, understand I also require an LLM model. Now for those LLM model, as I said, I'm going to use Hugging Face LLM model. Now that is the reason the access token that are actually created, right? I'm going to set up that access token with my Hugging Face. So I will write os.environ. Okay. And here, first let me go ahead and import os. Import os.environment, my Hugging Face hub API token. So I'm going to set this up as my API token, because from here Hugging Face hub only will be downloading the model, will be using the model, and here we are going to specifically use my token key, right? I'm hard coding the token over here because I've copied it from there itself, but don't use this because I'm going to regenerate that particular token. Okay, it will be of no use. Okay, now let's go ahead, and if you don't know about Hugging Face hub, guys, what exactly is a Hugging Face and all, I'll be writing some description over here for you all, right? So Hugging Face is a platform with over 350k models, 75k datasets, and 150k demo apps, all in Spaces, all open source and publicly available in an online platform where people can easily collaborate and build ML together. So I'm also going to use this same Hugging Face hub, and then I'm going to write from Langchain dot community, Langchain underscore community dot LLMs import Hugging Face hub, right? So I'm going to specifically use Hugging Face hub. I will create HF is nothing but Hugging Face hub. And now I will show you how you can call your models, right? The main parameter over here is nothing but you have to give your repo underscore ID. Okay. Now here, one repo ID, since we are going to use the open source model, is nothing but Mistral, right? So this is basically a skeleton for you. You can go ahead and replace the model whatever you want, right? So we are going to use Mistral 7B. Okay. Again, it is up to you, whatever model you specifically want to use. Only you have to give your repo ID. Along with this, one more parameter that you really want to give is model arguments. Okay. So in the model arguments here, we will specifically give temperature parameter. Okay. So temperature will be nothing but it will be 0.1. And the next parameter that you're specifically going to give is nothing but max underscore length. Okay. And this max underscore length will be nothing but 500. Okay. So these are the two parameters that you really need to create so that you will be able to use this particular open source model. Understand one thing, this will be directly using from the Hugging Face hub itself. Okay. You don't need to download it locally. For downloading, if you want to download it locally and probably want to check it out, so I will also give you the code for that, which you can try it out. Okay. Now let me go ahead and write the same query. So I will say query is equal to what is the health, same query, insurance coverage. Okay. So this is the query that I have. Now in order to invoke it, I will use the same hf.invoke. Okay. And then I'm going to basically give my query. So here you can see now I will be able to get my response. And this is the most generic response, right? What is the health insurance cover? I have just asked. This is the most generic response which Mistral knows. But my main aim is to probably create a Q&A app, right? Q&A app specifically for RAG application. So still it is not communicating with my data that is available in my PDF. Okay. So right now this is just given me a general output. Okay. General output, what is available with respect to the knowledge of the internet. Now the next step, what we are specifically going to do. See, understand, if you want to make sure that we interact with our PDFs, this Hugging Face LLM models, we have to probably create our own prompt template. One more thing that I really wanted to show is that if you want to download locally, right? Hugging Face models can be run locally through Hugging Face pipeline. So here is the new code. Before we used to use Hugging Face hub. Here you have Hugging Face pipeline. Same code for task generation, everything. You can probably execute this, and this will basically be able to generate it. Okay. But I'm not going to use this since I've already trying to use from this, right? So it is going to take some amount of time with respect to execution. Perfect. Now this is done. Now, as I know, I need to use this LLM model to interact with my PDFs. So for that, I will try to create my prompt template. Okay. Now the prompt template will be nothing but I'll be use the following piece of context, okay, to answer the question asked. Okay. So here is the simple prompt that I have used. Use the following piece of context to answer the question asked. Please try to provide the answers only based on the context. Okay, so I'm just giving a simple prompt. Okay, pretty simple prompt. Okay, now my context will be over here, context. Okay, and then my question will be nothing but it will be over here. And I think we have done this many number of times in my previous video. Okay, and if I want one more thing, I can probably give. I will just write helpful answers. Okay, and I'll keep it blank. Okay. So this is my prompt template that I'm going to use. And then in order to make it as a this, I'm going to use my prompt template. My template will be assigned to this same prompt. Same prompt. I think this is assigned to this prompt. Okay. So this will basically be my prompt. Okay. And then my input variables will be having two things. One is context. Okay. Context, and the other one is question. Oops. Same question. Just a second. Question. Okay. So context and question, we are setting it as an input variable, and this basically becomes my prompt itself. Okay. So I'm going to execute this. Okay. Now understand, if I want to combine, okay, if I want to combine my LangChain, right? Sorry, not LangChain, my template with the LLM models, obviously what you really need to do so that we also get the context and the question, it's create retrieval QA, right? So create retrieval QA chain, right? So if you remember that in my previous video, one more way that I can specifically do is by using this retrieval QA, right? And in order to use this retrieval QA, here what I will do, I will just write from chain type, okay, from chain type, and here I'll start giving my parameters that I require. First parameter is nothing but LLM. LLM will be nothing but chef, whatever the Hugging Face library that we have created. I will create my chain type as stuff. Okay. So chain type will be nothing but stuff. The next parameter that we are specifically going to do is my retriever, which will be assigned to my retriever itself, which is basically defined. Return source document. You can keep it as true or false so that you'll be able to understand from where it is basically coming up. So return source documents, which will be assigned to true. Okay. And the next parameter is nothing but it is my chain type. Chain type KWARGS. Okay. And you can also check out this entire documentation from the LangChain documentation. So prompt will be nothing but it will be assigned to this particular prompt. Okay. Sorry, this prompt. So this is done. Like most of the things has been completed over here, but understand one thing, in retrieval QA, you have to give your Hugging Face, your chain type stuff, your retriever, return source document, so that you need to understand from where it is coming. And chain type arguments is nothing but with respect to the prompt. So this prompt will return some of the documents. It will be setting up in the context. Then the question will go over there, and entire this retrieval QA chain will work. Okay. So here I'm going to write it as retrieval QA. Right. So this will basically be there. Let me quickly go ahead and execute it. Okay. Now it's final that you just need to run it. In order to run it, here is the question, right? So now finally we can use this retrieval QA that we have actually created, and we are invoking with respect to the query that we have already written, what is the health coverage. And finally, let's go ahead and check our results. So here you can see what is health and insurance covers. The brief presents the state level estimates of this American Community Survey. The US Census Bureau conducts the ACS throughout the year. The survey asks response to report the coverage at a time. So every information is specifically given. Now you can go ahead and ask some other questions also if you want. Let me go ahead and ask this. Differences in the uninsured rate by state. Okay. So I'll go ahead and ask this. Let me go ahead and write my new query. So query is equal to let me just go ahead and close this in. Okay. So here is my query. So let me go ahead and execute it. Now, if I go ahead and see this, it should be able to give me the response. So here is a comparison of ACM measure of health insurance. So everything is probably matching over here. See, uninsured rates of this is coming up. Okay. So all the information are specifically coming up from here. This is perfect. Now I've also shown you how you can probably work with LangChain and Hugging Face. So let me go ahead and update this also if you want. Okay. Insert cell, chain cell to insert. Okay, so perfect. This is it. I hope you like this particular video. At the end of the day, the one thing that I really want to say is that more you practice things, more you see things, definitely you'll be able to achieve multiple things over here. So yes, I hope you like this particular video. This was it from my side. I'll see you all in the next video. Have a great day ahead. Thank you, one all. Take care. Bye bye.